My name is Denny Adams, and I work with channels at Blueworx, and I certainly appreciate everyone's time. Today, we're going to give you an introduction to Blueworx and our products. I should tell you that it's going to be more toward our Linux platform and not about our AIX platform. We do have a lot more sessions coming up. We have multi-day training sessions available, so we can deep dive as much as need be to help you guys get up to speed on this. The session is being recorded, so I'll send out a link after this so you can go back. I know there's some people that were traveling, wanted to be on and couldn't, so they'll be able to go through this. Please ask questions. If you know, you can also email me the questions, and I will get you answers to those questions. We again certainly appreciate your time. Delighted to be working with you, and let's get started. So I'm going to turn it over to Dean and Hersley, and let's get going. And again, let's make it interactive as possible, and have a good session here. Thank you.
Thank you, Denny. Hi, this is Dean Upton, based over here at the Development Labs in England. And as Denny said, we'd really appreciate it if this is an interactive session. It's relatively new material here, so I'm sure there's going to be a few things that we've missed out, and you know, if we can uncover those, it'll be very useful. So the agenda for today is about giving you an introduction to Blueworx, the software that we use, architecture, moving on to how we install, configure, develop, and do problem determination, followed by some demos at the very end. So the first thing we'd like to cover is the introduction to the Blueworx organization. I mean, as you know, Blueworx is a new company, but the team and the software certainly isn't. We have a strong heritage, which I'd like to share with you. And I've asked Tom Fetters from Blueworx to give an overview. So, Tom, I'm going to hand over to you.
Well, just to echo what both Denny and Dean have said, we really do appreciate everybody participating in the session today. You know, the folks in Hersley are probably thinking, boy, why didn't we start this any earlier? But I give credit to the people on the East Coast and Central time zones, and even if we've got Mountain and Pacific time zones, that they started their day very, very early today with this session. 8 o'clock on the East Coast, and make it 5 o'clock on the West Coast if we've got anybody. So thank you for participating. As both Denny and Dean have said, if you've got questions, stop me and ask them as I'm going. I think these sessions always work better if they're interactive sessions. So I look forward to any questions that you have. Wanted to start out by telling you a little bit about Blueworx. Blueworx is a division of the Waterfield company, Waterfield LLC. Blueworx is a brand new company. It started on February 1st of this year, when the sale was final of the Webster voice response products from IBM to Waterfield. Blueworx was created just for that event and the sale of those products and the development of those products and the support of those products. But Waterfield is not a new company. The heritage of Waterfield goes all the way back to the 1920s when they got into the financial services business. And over time, they became the largest private mortgage company in North America. There seems to be a lot of background noise. There we go. Whoever was doing that, thank you for muting. But as I was saying, the heritage of Waterfield goes all the way back to the 1920s when they got into the mortgage business, and over time they evolved to become the largest private mortgage company in North America. One of the Waterfields had the bright idea in the early 2000s that the future of the mortgage business is something that might be a little bit precarious to have all your eggs in just that one basket. So they started looking at strategies for diversification. One of the strategies they came up with was an oil and gas exploration company, and that's called Waterfield Energy. Another one was Waterfield Technology Incorporated. That is a company that is a sister company of Blueworx. It's a company that's all things call center. So they're an OEM reseller of platforms such as Aspect, Genesis, workforce optimization. If you think of all of the different pillars for technology within the call center, Waterfield has a play with each one of those components and resells products in that industry. So not only have they been selling it, but they've been providing application development, integration services, and delivery and support of those things since the early 2000s. They then bought a company called Chrysalis. Chrysalis is a applications development and systems integration company that is based on the West Coast in California. They're a company that's been around for a long, long time. Years and years ago, in the mid-1990s, I was with Bell South when we created a group that was advanced call center applications group. And what we found out is we could sell those applications a whole lot easier than we could deploy it. Well, when we ran into deployment problems, we took a step back and said, what can we do to supplement our efforts at Bell South and bring forward subject matter expertise in not only application development, but systems integration and support. And Chrysalis was one of the companies that we contracted with back in probably 1994. So that'll show you how long they've been around to help us with that. And nothing happens in this business overnight, but as close to overnight as could be seen, they helped us with those deployments. The things that we were selling were actually working. Customers were happy with them. They were starting to establish their ROIs. So the two sister companies of Blueworx are Chrysalis and Waterfield Technologies Incorporated. All three of us sitting under Waterfield LLC. So if somebody asks you a question, is Blueworx a new company? I may not have heard of those people. The answer is yes and no. We are a new company, but our heritage goes back for years and years and years. Offices throughout this country and in the UK. Headquarters is in Tulsa. We also have offices in New York and Los Angeles. And we are also, what I would call a modern day virtual company. That we've got people spread throughout the country. We've got multiple people in Indiana, multiple people in North Carolina and Georgia and in Florida. So the reality is, we are close to you. We're willing to be in the field with your customers, with your prospects, supporting you. Feel free to call on us and we'll be there for you. So what did we inherit, when we became part of the Waterfield company? I think one of the things that impressed me so much, it may sound a little trite, their focus on customer first and, trying to do absolutely everything they can to make sure that that customer has a positive experience. Hopefully at the end of the, if it's a support call or a, request for a price quote or anything that would prompt a customer to call into us or a partner to call into us, that customer or partner at the end of the day says, look at what Blueworx did for me. And not to me. That is our goal with each and every interaction that we have in the marketplace. So, how do we do that? We do that by, first of all, having a support environment that works around the clock. We're listening, and as we listen, we're not just listening to come up with an answer. We're listening to try to understand, what is this customer going through? What are they trying to accomplish? What are their problems? And that, quite often, that listening ends up, evolving into us asking multiple questions and going multiple layers deeper than that customer was even thinking that we might. But the key is, we've got to understand where they're at and where they're going to be able to help them establish the roadmap to get from one to the other. The focus this year in particular, more so than ever, was absolutely on customer retention over customer acquisition. Quite often internally, we talk about the goal in 2016 in Blueworx was to maintain the beachhead, where going forward, and this is probably the start of the going forward strategy, is to start climbing the hill and building the company. But the reality of this year, our goal was to maintain our customer base, make sure that they were happy, make sure that they saw a future, and make sure that they were going to continue doing business with us. And I think by all accounts, we've been hugely successful in that area. A lot of people asked us, they said, why are you getting into this business? The IVR business, isn't that a dead business? Aren't calls that are being satisfied in an IVR decreasing over time? Well, the sheer reality of it is it's almost like a Mark Twain novel where, he at one time said, the rumors of my death are greatly exaggerated. The rumors of the death of the IVR business and the call center business are also greatly exaggerated. Everybody was absolutely convinced that the World Wide Web, or the internet, was going to kill the call center business and the IVR business, or the self-service component of that call center business. The reality is it's actually had the opposite effect, that many people actually call in to verify information that they've received over the internet, or they'll gain information over the internet and have additional questions that they need to go deeper, and you have to have a live interactive conversation with a call center agent, or with a self-service component into that call center. So quite the opposite has happened. IVRs are being used for many, many more things today than they were originally. It's not just inbound. Outbound is an application that is used on a regular basis, and that certainly augments the number of transactions that are happening in an IVR. So the bottom line is, why did we acquire WebSphere Voice Response, is we think that this marketplace is absolutely ripe for expansion. It is not, plateauing or decreasing over time at all, as some others would have thought. The other reason we decided to buy WebSphere Voice Response, and I've been in the IVR business for 20 plus years. When I looked at WebSphere Voice Response as an outsider, as a competitor, I took a step back and said, wow, there is another platform in the marketplace that is any more reliable, any more scalable, any more flexible. It may not have some of the things on the outside of it, but when it comes to being a rock solid platform, that platform is absolutely second to none. So that absolutely had a big play on why we acquired the technology. Um, you know, as we're talking to customers, you know, their first reaction was, well, what does this mean to me? You know, I've been doing business on this platform with IBM for 10, 12, 15 years. You know, who is this Blueworx, and you know, what sort of impact will I see? Well, the reality is it really is the best of all worlds. The platform came over intact. So all of those assets that it brought forward, reliability, scalability, flexibility, things like that, those will continue on. But the best of all worlds also comes with an investment into the platform and a commitment to evolve that platform to include, you know, new development environments, new operating systems, new deployment strategies. So it's not just a premise-based platform anymore. You know, it's a platform that can be supported through cloud architecture as well as premise-based architecture. It gave, you know, that roadmap came in really almost 3 flavors, and you'll see that today. You know, others will go into it in more detail than I, but there's a short-term version of the roadmap, there's a medium-term version of the roadmap, and a long-term version of the roadmap. You know, when IBM was supporting this product for at least the last half dozen years, roadmap discussions did not occur because there wasn't, you know, a defined future to the platform. The group in Hersley did an absolute fabulous job of trying to respond to customer needs, but there were more customer needs than there were time or bodies to apply toward that, or certainly money to apply to that. All of that has changed now. You know, resources have increased, financial investment has increased toward that roadmap, and as you'll see, the number of deliverables that we've already made in 2016 absolutely echoes the fact that, you know, not only are we talking about a future for the product, but we're demonstrating a future for the product. Within the industry, what we're doing is absolutely being recognized. Forever and ever and ever, probably the lead spokesperson for the industry is a guy by the name of Dan Miller, who is with Opus Research. And Dan says that, you know, he was quoted as saying, Blueworx combines a well-regarded world-class support organization with a workhorse of a self-service platform. Existing customers, as well as prospects, looking for a solution provider focused on the optimal IVR platform should absolutely take note. You know, at the end of the day, I'm not sure that we could have received better accolades or a better pat on the back that our strategy was sound, and it certainly gave us the confidence with people like Dan Miller in the industry taking a step back and recognizing the direction that we're going was a solid one. So I'm not going to go through these one by one. We'll just put them up. This may be the appropriate time to talk about some of the questions that you might have about who is Blueworx. You know, and we can kind of flip through these things. If you don't see the questions that you have, you know, please feel free to ask, you know, whatever questions you might have. Maybe the answer to your question is already right here, and we can talk about it or go into greater detail. So I'll just kind of open it up at this stage to see if there are any questions, and if not, I'll kind of come back and do a summary of who is Blueworx and what are we all about. I think one of the things that was, to me, a great testimonial of the strategy of Blueworx is each and every person that worked in the former group at IBM was given an opportunity to either stay with IBM or to come over and work for Blueworx. And at the end, when the transaction was closed, what we found is 100% of that team came over to Blueworx and is now full-time employees with Blueworx. As I look at this and take a step back, I asked myself as I was getting ready for this presentation today, if I were in your shoes as a partner, why would I be excited about working with Blueworx? Well, it really falls into multiple categories. One of them is, and they'll go into it in greater detail, is they are committed to an agile development environment. It used to be in the old IBM days, everything was done in waterfall. And the reality is, once something got spec'd and development began, you didn't see a new feature for 2 to 3 years on that. Where in an agile development environment, I can, bring something to the Hersley group, Dean and Paul in particular, and we can talk about it. We can talk about the benefit of providing this, the usability of, a new feature, not only that was presented by one customer, but across our customer board. They'll talk with me about the complexity of the development of that particular thing. But often, and I will tell you multiple times, things that we've discussed that our customers have shared with us, the development team in Hersley has said, Tom, it's going to be 8 weeks until we can get you that. Or it might be 4 weeks until we can make that happen. But with that agile development environment, it is just that. It's 4 weeks or 8 weeks many times, and it's not 2 years and 3 years. So we're much, much more responsive to the marketplace, to our customers there. The number of releases, updates, features that have come out this year, to me, is staggering when I look back. As new technologies come into this marketplace, the ability to integrate with those is substantial. To give you a good example, and we'll talk about it later in the day, is the integration with cognitive business decision-making engines like Watson. I think that is going to, be a watershed event for the IVR industry. When an IVR connects with a cognitive business decision-making engine, such as Watson. That would have been unheard of, before, but, a couple things happen now. One, it's an agile environment, so we can focus our efforts on that, deliver to the marketplace in a much shorter time frame. But we can also fall back onto what this group was all about and where they're located, that they're co-located with many, many of the developers that are working on Watson. So, as it turned out, I think it's a matter of time before it's going to be announced that we're the first IVR platform to fully integrate with Watson. So you should see that press release coming out. And that was done, one, because of an agile development environment, but two, the co-location and the ability to interact with the development team on Watson to figure out what was the best way for those two products to come together. Okay. Are there questions out there? Okay. I'm going to take the silence as either I've lost my connection you've lost your connection, or I'm answering all your questions. Let's go with the third. So kind of in summary, you know, the summary thoughts that I have in, you know, as you plow headfirst into this training, these are probably some of the things that you want to test. You know, at the end of the day, come back and ask these questions to yourself and say, you know, is Blueworx passionate about exceeding our expectations as a partner, as well as my customers' expectations? You know, is Blueworx willing and able to, you know, not just take our business, but to earn our business? All too often in this industry, to me, the OEMs call up at the end of the quarter and say, okay, what have you sold this quarter? The reality I think you'll see from Blueworx and the program that Denny has put together, it's not that at all. We're going to be there with you, rolling up our sleeves, designing the appropriate solutions for your customers, selling those solutions to your customers, providing them the ROI, you know, providing competitive differentiation. I hope you see that, you know, because that's where we're trying to take this. We're not new to this. You know, Blueworx has only been around since February 1 of 2016, but the reality is we've got, you know, hundreds and hundreds of years of experience in the IVR business. Many of the people inside of Blueworx have been working in the IVR business double-digit number of years. You know, some of them, like myself, in excess of 20 years. And I won't tell you how many years in excess of 20, but that'll probably define my age. But nonetheless, there's nothing new about this business to us. We understand it, and we understand what makes it go. We understand what makes it tick. We are willing to invest in the platform. You know, I don't know what the actual number of dollars is that we put into development, but you know, when you see the number of features and releases and advances that we've brought to the marketplace in this product set already this year, and what we have planned over the next year, 2 years to 5 years, you can't but help walk away and say they are absolutely investing in that platform. So, you know, we're committed to help you, you know, make this a great partnership, and I'm confident that you'll see that. Dean, that's all I have. I'd be more than happy to answer any questions if anybody has them.
Thank you so much, Tom. Just with regards to questions, some people may have problems with audio, so feel free to use the chat box at the bottom of GoToMeeting, and we'll have somebody answer there or interrupt the current speaker. Alternatively, you can email any of us after the event, and we'll happily provide you with answers. Okay, Tom, I'll just regain control from you.
You're always doing that to me, Dean.
Okay, so next thing we're going to talk about is more about the software, the background behind the software, where it comes from, its strengths, and how it's developed, before we actually dive into a description of the software itself. So bear with me a second, and I'll bring up that slide. Okay, so we're going to go through where we've come from, our strengths, our benefits, how we integrate with Watson, and how we develop our software. So the voice response product is actually 25 years old. The code was originally developed by IBM. It was known as IBM DirectTalk 6000, and then IBM WebSphere Voice Response for AIX. And it was designed from the beginning to be a very high availability, very reliable, strong, carrier-grade platform. And they were aiming for 99.999% availability. And so in IBM style, it was very much over-engineered. It was based around AIX with a sister product on OS2 or Windows. AIX provided the reliability, both in terms of hardware and operating system, to provide that kind of availability. And so it ran, the AIX products ran on the IBM RISC or Power or P-series hardware exclusively. The Windows products was discontinued quite some time ago now, about 15 years ago or so. But throughout that time, the product was continuously enhanced and developed with new versions being released, but we always maintained backwards compatibility for applications. And wherever possible, we try to ensure that we didn't provide a burden on our customers in having to adapt or recode their applications. And even the latest version of Blueworx voice response for AIX runs applications that are 20 years old. So the foundation of the product, in fact, all of our products, are around stability, and this is proven. We have customers taking millions of calls a day who we speak to on a regular basis, and their system hasn't gone down. There is no downtime. So it's not just something we aim for, it's something that we've proven. Also, in the last 5 years, we've had a focus on scalability, particularly as we start aiming towards the cloud. And so we can scale way beyond any of our competitors in terms of the number of concurrent calls. We also try to provide customers with a maximum flexibility. So we don't lock customers into a particular development environment or a particular platform. Wherever possible, we use open standards, and we try and provide customers with the environment that they want to run in. On top of that, we have always been very proud of our support for our customers. And over the last 25 years, whenever there's been a problem or a trouble ticket opened, we have taken ownership of that, regardless of which component or which piece of software is to blame. And we focus on solving the problem, not just fixing any bugs in the code. And finally, more than ever, we are responsive to change. We recognize that this is a very fast-changing industry. And so we now try to communicate with customers as often as we can, try and understand their requirements, try and understand how the industry is changing, and change our development priorities to meet those needs as quickly as possible. So as of today, pretty much, we have 3 different platforms as part of our offerings. The first one is the heritage product, the Blueworx 7 for AIX. This offers full support for all of the legacy as well as modern applications. And this runs on AIX, and so requires IBM Power hardware and virtual machines. This software, as I say, has decades of proven reliability, and it was designed to be rock solid, and the applications have proven to be that way. But there were definitely some customers that didn't want to invest in Power hardware or weren't familiar with AIX, and so requested a Linux product. And so this year we launched Blueworx 7 for Linux, which runs on Red Hat 6.5 or the equivalent CentOS. And this enables you to run on Intel hardware as well as Linux on Power, or even System Z mainframes, and we've even tested it on Raspberry Pi, which some of you may be familiar with. Again, it uses the same foundation as AIX. It's designed to be very reliable, very scalable, and has a different set of functionality to the AIX product. So they're really sister products. It's not just a direct port. And I'll go into that shortly. Finally, we have our new cloud offering. And this uses the Linux code base. So whatever we provide you with the Linux code is what we use ourselves for our cloud. And we offer several different options for the cloud. We can completely manage the system, and you can use the shared cloud along with other customers. You can have your own private cloud, which we will manage for you. Or you can have your own system, your own licenses, your own system which you manage, but in our cloud. We have various options for cloud. So an overview of the generic functions. As I mentioned earlier, it's an open systems architecture with pure open standard support. We do not lock you in. We do not insist on a particular environment. You can take an application that's written in voice XML for Blueworx, and you can use it on another IVR if you wanted to. So there's absolutely no lock-in. We support VXML, CCXML, MRCP, all the industry standards. You can write applications in anything that generates voice XML, such as JSPs or even PHP. There's also support for legacy state tables, which are from the AIX product. It was a proprietary language way back then, 25 years ago, long before the advent of voice XML. But we still support state tables in the AIX product, as well as being able to write applications in Java and C. We support 480 channels per virtual machine, and we scale by using multiple virtual machines. And at the moment, the limit is 500 for Linux, although we're looking to increase that. We have engineered the core of the product so that it can take advantage of multiple cores. And so we can scale much higher than we used to be able to, say, 10 years ago. And so we really are able to run an unlimited number of virtual machines, dependent only upon the processing power and memory. We support voice over IP, SIP, as well as traditional TDM, T1, E1, ISDN using media gateways. We offer CTI integration with the market leaders, Genesis, Avaya, Cisco, etc. And there's also a sister product for Blueworx Voice Response for AIX, which provides a sophisticated unified messaging system. We offer the support for speech recognition and text-to-speech through any MRCP compliant speech engine. So that includes Nuance, LumenVox, and also IBM Watson Speech. Finally, as I said, we provide flexible deployment options. You can use the hardware on your own premises if you wish, and buy licenses and run it there, or you can run it on the cloud, or you could have a hybrid of the two and have your own premises with a failover to the cloud if you suffer a failure or a sudden surge in traffic. So I think many people on this call are more interested in the Linux product. So I'm just going to go into a little bit more detail of that one. This is a new product designed from scratch using the design principles and the lessons that we learned from the reliability of the AIX product. And we use very new development methods and modern design methodologies, so there's no legacy to hold us back. It was designed from the ground up to be SIP, and just like the AIX product, we've tested it thoroughly to make sure that it's incredibly robust. At the same time, it's designed to be very lean, it has a tiny footprint, as well as being high performance. So we keep it streamlined so that it can scale high with the fewest resources. It really requires just the Linux operating system and a JVM. It doesn't require anything else to run. And it has a very simple configuration. It's a text file based configuration, which makes it easier to manage multiple systems. And it's all part of the lean approach. Again, we support Voice XML version 2.1, MRCP2, C6ML1. And you'll notice that the one thing that it doesn't support is the legacy applications that were built for WebSphere Voice Response for AIX. So those are state tables and custom servers. So whilst the AIX product supports legacy applications. The Linux product doesn't and will not. It's purely around the modern industry standards. And as I said, at the moment, the limit is 500 channels per virtual machine. Again, we're looking to increase that, but we achieve scale using multiple virtual machines and load balancing. So just to avoid any confusion between the Linux and the AIX product, if you can see the timeline across the bottom there, we started out by taking a tiny part of the AIX source code base. So some of the features, some of the functionality from AIX, and we built upon that to deliver the Linux code base. And then over time, we've developed the Linux code base and backported that into the AIX code base. So you can see over time, the AIX product continues to grow, and that's our plan. We're not abandoning the AIX product at all. So the development that we do for Linux will benefit AIX and vice versa. So over time, you can see the Linux code base increases, as does the AIX code base. And increasingly, there'll be more and more overlap between the two. However, even at the end there, you can see that there are still some things that AIX can do that Linux can't, and vice versa. So if you're unsure which platform to use, get in touch with the team here. We're always listening, and we can provide you with some advice as to which would be the best platform for you. And just to mention there that the cloud service uses the Linux product, just for reference. I mentioned that high density and virtualization has been the key focus for the last few years. And now we really are built to be virtualized. The number of LPARs, logical partitions, that's AIX speak for a virtual machine, is limited only by CPU power now. We used to be limited to 2 VMs per physical machine, and then we increased that, and now we've made it unlimited. And so you can achieve a very high number of channels for a certain amount of rack space. In fact, in that photo there, you can see that blade tensor's running 56,000 channels, and we're pushing to increase that all the time. So on AIX, you can use power LPARs. We require a relative performance, which again is an AIX term, of 26 for each virtual machines, which will run 480 channels. The Intel machines scale 500 channels per VM and requires 4 2.7 gigahertz cores for every 500 channels. And I'm not particularly familiar with BOGO MIPS, but my team around me nodding confidently that is a recognized term. So 5,400 BOGO MIPS per core is required. As Tom mentioned, the development team here are based at IBM Hursley Laboratories, development laboratories, which is where most of us have spent most of our careers. We worked for IBM previously. My colleague and I have worked here for 16 years, and so we developed a strong network of people who work within IBM, and many of whom have moved over to developing for Watson. And so we've leveraged those links that we have to understand how they're developing the product, where they're taking it, which APIs they're going to be supporting, and working with them to figure out how best to integrate with our products. So there's a team, some of whom may be on this call, I think, who have been working to provide an MRCP connector to IBM Watson Speech. Watson Speech have their own API, but the industry standard is MRCP. And so they have provided this connector, developed and provided this connector, which enables us to talk MRCP, and they will talk to Watson Speech. And the results are really impressive. I believe that they've been using BVR to test their MRCP connector. And we have exclusive rights to use that MRCP connector for Watson. We're in the process at the moment of acquiring Watson certification, so you should see that soon. The next aspect of Watson is around the cognitive services. This really comes into its own when you start looking at conversation and unstructured data. Watson has various services. The ones that interest us, and maybe yourselves, are the ability to take free-form text and speech and try and understand what the person who's talking is wanting, or what they're talking about. And then harvest information from many different data backends, a mass of unstructured data, and try and pick out the aspects that are useful to this particular interaction. And so it may be that if I go through these use cases at the bottom, you could have a caller who calls a tech support helpline. Watson transcribes whatever they say, and then uses the text analysis to determine the answer based on previous answers that agents have provided, and even that it has provided in the past and has been successful. So it learns from previous interactions. You could also have intelligent call routing, say to understand what the reason is for the call. Use sentiment analysis from Watson to try and understand whether the caller is angry or happy or agnostic, and then route the call round to the appropriate agent, maybe straight to a supervisor if they sound annoyed. And then finally, there's this is actually a real-world example, a personal sales assistant, where somebody could ask about products, services, or facilities in a particular store in natural language, and the system could learn about their likes, dislikes, and make an outbound call when special offers are available which would interest that particular customer. So just a few use cases there, but really Watson is so powerful and flexible that really only limited by imagination at this stage. Next thing I want to mention a little about our development process, and I'm mentioning this because it is at the foundation of how we are able to deliver our products. What I'm looking for. Very quickly in response to our customers. This is our development vision here at Hursley. We aim to lead the industry through innovative solutions that provide the most reliable and scalable IVR on a choice of platforms while responding quickly to the continuously changing needs of our customers. The way we do that is by moving over to agile development, which is what we did about five years ago. Our old process was around a 2 to 3 year process where we would talk with customers, understand their requirements, develop, then test, and then finally release and support the product 2 to 3 years later, by which point many of the customers' requirements had changed or the software was already out of date. So we've replaced that with agile development, which allows us to listen to customers and take that feedback and feed it into the priorities, then develop and test and release in a much tighter loop. So we ship a smaller amount of content, but very responsibly, so we can provide you exactly what you need as soon as possible. And to date, we have shipped around 12 feature packs for AIX, and Linux is on a continuous development basis, so it's constantly improving. Our roadmap is based around 3 initiatives, and so we're constantly working on improving our platforms, which has been evident this year as we've added Linux and cloud to the offerings, as well as providing the tools that customers need to develop and maintain their IVR. And the third initiative is around intelligence, particularly around the integration with Watson. But you can see that we have an emergency lane on the right-hand side there, and that allows us to talk with customers, understand if there's something that they need urgently, and we can develop that, slip it into the development stream, and deliver it much quicker than we used to be able to. Typically, we've delivered things in around 6 weeks when needed. So already you can see that this process is working really well for us. This year, since Blueworx started, which was around 9 months ago, we have delivered the Linux offering. We've updated AIX to version 7. We've launched our cloud offering, and we're now working on a web portal for provisioning that cloud service. So in summary, we embrace the open standards, the open architecture, and we absolutely do not lock you in to our platform. We're extremely stable, and that's proven. We offer unparalleled scale. We have no concerns about going well beyond 100,000 simultaneous calls. You can use Linux, AX, or cloud, on-prem, in our cloud, or a hybrid if you wish. We're constantly working with the Watson team to figure out how best to integrate. And what underlines all of this is that we are passionate about customer service. We want to stay in touch with you. We want to understand if there's anything that you need to do that the product doesn't offer, and we want to do our best to incorporate that into the product. Okay. So the next session is going to be presented by Paul Blanco. Paul and I have worked together for 16 years in the same team, and unfortunately for Paul, sitting next to each other as well. So we've worked together in various aspects of IBM in the voice team on WebSphere Voice Response and now Blueworx Voice Response. And Paul's now responsible for the architecture of what we deliver. So I'm going to ask Paul to give an overview of BVR's architecture. Paul, I'll just hand control over to you.
Thanks, Dean. So while Dean's handing the screen control over to me, as Dean said, we've worked together for quite a while. And so my job role is as the Director of Platform Architecture. So I'm responsible really for, I guess, the way we do things and who in our team does them, rather than necessarily what we're doing. So, I work very closely with Dean. Dean's role is more aligned with deciding where the platform goes and the things we're going to add in, and my role is more about how we do that, how we add that into the platform, and who in the team does that work. So if I just bring up. Great. Okay, so the presentation I'm going through now really goes through an overview of the architecture of the Linux platform, BVR Linux. I talk a little bit about the differences between the AX platform and the Linux platform, and some of the slides cover similar things to Dean, the slides that Dean just presented, but I'll skip through those. And as we said all along, if there are any questions, feel free to shout up and we'll try and answer them, or there's a group chat going on GoToMeeting as well, so feel free to ask questions in there. So kind of three things I'm going over mainly: a discussion of the differences between the two platforms, the AX and the Linux platform, a look at the architecture of our Linux platform. So this is the new code we've released and we're working on right now. And then talk a brief chat about licensing, how the product's licensed, where you get the license from, and the things that allows you to do. So Dean, as I said, Dean covered some of this in his slides. I just wanted to go over it in a little more detail. So as Dean said, we have three platforms really. We have a cloud platform, but then we have the Linux and the AX platform. And the AX code, as Dean said, is very mature. I mean, it's 20+ years in development. It's been around ever since I joined the team, and it was around for a good 5-6 years before that too. It has a very rich feature set, and a lot of things in the platform that were important 20 years ago and aren't necessarily as important now. It has support for both TDM and SIP, and that's kind of a key differentiator between the platforms. Really, is the Linux platform is SIP only. Again, as Dean covered, 480 channels or individual phone calls per BVR instance, but it is supported in a virtual machine environment in AIXL bars. Another key difference here is the MRCP support, and this is for connectivity to speech vendors. We support MRCP version 1 in the AIX platform and MRCP version 2 in the Linux platform. But one of the things that one of the slides Dean brought up kind of talks about how we're developing both platforms, and features that we add into one, we're going to then merge across into the other platform. So as part of that plan, the MRCP2 support that we've added into the Linux platform, we're going to put back into the AX platform too. For application development, voice XML, CCXML, and I think Dean mentioned the legacy support for state table applications and custom servers. Excuse me. Because it's an AX platform, it has a reliance on IBM's power hardware. So we support anything from Power 5 and above, and we support, as it says, AX 6.1 through to AX 7.2. Now the Linux platform is something we were keen to do for a long time, and while we were IBM, it was kind of difficult to get the kind of financial input to allow us to do that. Now we've moved to Blueworx. It was a perfect opportunity to get that code out, and so we started work on it at IBM, but we finished that work off pretty sharpish when we became Blueworx, and we released that platform. When was it, Dean? Was it March or April this year?
It was April.
So we released that in April, and as it says there, it's got a smaller feature set than the AX platform, but then a lot of those features in AX that we don't support in Linux, we don't need to support anymore because technology's moved on. And I guess one good example of that would be the AX platform supports connectivity to mainframes via a 3270 interface, so that you can write your state table application and access back-end data from your 3270 mainframe. The way you do that these days has moved on. That kind of app connectivity you can do in the JSP on the web server that serves up your voice XML application. So although there's a smaller feature set in the Linux platform, a lot of those features are just no longer needed. So as Dean highlighted, we support 500 channels per instance on Linux. And we like to get feedback from our customers, and if feedback is that actually it would be nice if we could support more channels. The only reason we stopped at 500 channels, there was no reason in the code that made us stop at 500 channels. It was more of a, we had the facility to test 500 channels. And so if there's a requirement to increase that to 1,000 channels per instance, for example, it's just a matter of testing. And so that's the advantage of the Linux platform is it's new code, a lot of new code, and so we have a much better ability to go in there, change things, and double the number of channels we support. As I mentioned, MRCP version 2 supports, again, voice XML and CCXML. And Dean's already said it runs on Intel, it runs on Power, it runs on System Z, it runs on Raspberry Pi. But the main kind of, I guess, selling point is the difference between it running on Intel rather than on Power hardware. And again, highlighting 64-bit Red Hat, 6.x, and CentOS 6.x. So just reiterating, Dean had this slide, the exact same slide. It's just to say that we've been working on the Linux code base for the last I guess 6 months, adding features to it, extending support for things, but also at the same time we're working on things in the AX code base, and what we're trying to do is merge them closer together. So features we add into Linux that are advantageous for our customers, we're going to add into the AX platform as well to benefit our current customers and to benefit new customers who are interested in Power hardware in the AX platform. And as Dean said, I'm going to highlight this again, that the cloud service is based upon the Linux code base. So it's a Linux product running on Intel, running in SoftLayer, running in AWS. So this next slide is I guess, getting quite technical, and really it's just to give an indication of how the internals of the code work, so that I can highlight some key areas, some key things we do, yeah, I guess it just shows how the code works. So as you can see on that diagram, the key piece in the middle there, the call processing component, is an event-based component. So it takes events in from all the other components and deals with those events and passes information on and things like that. And so the key things on there are the voice XML and CC XML, the application layer at the top. Those two components, the voice XML browser and the CC XML browser, are the exact same browsers that are in the AX platform. And so we took those pieces of code, those proven, reliable browsers that our current customers have been using for the last 10 years or so, and we used those to base our Linux platform on. So we've got those proven and reliable pieces of code there, and all we're doing is interfacing into them in a slightly different way. And as you can see, they fetch voice XML and CC XML applications from web servers using HTTP, HTTPS in the same way as any other voice XML browser does. Underneath the call processing layer in the diagram, we've got the kind of interfaces into the telephony network, into the voice over IP and SIP data, and that's the signaling stack on the right-hand side there, and the streaming on the left-hand side. Those are the two pieces that kind of take the telephone call, take the SIP invite in, decide what to do with it, and handle the audio streaming. And so I guess the important bit in this diagram is that all of the stuff above the DTNA down the bottom is written in Java, and the DTNA is written in C. And the reason for this is the DTNA handles those 500 or 1,000 telephone calls worth of audio data. And so what we needed, the performance that you get from a C is actually a Linux kernel module. We needed that performance that you can get only from a Linux kernel module to handle that amount of audio data. And the only other thing on there really to kind of highlight is the MRCP version 2 connection, I guess, that component. And that's the piece that we've written for the Linux platform, but now we have this component that we can plug into the AX platform. And so that's how, the way we're componentizing the code we're writing now means you can easily take that piece of code and add it into AX, and anything we write on AX you can take and put into Linux. And so it's that MRCP version 2 component there that allows us to talk to any MRCP version 2 compliant speech server. And so on the chat there, I kind of already mentioned, but we test regularly in-house with Nuance and Blueworx, and we're actually Blueworx certified partners. So there's an announcement, press release that talks about that. But that has allowed us now, because we're MRCP version 2 compliant, the IBM Watson team are working on an MRCP version 2 connector into their Watson services, and that allows us to plug directly into that component too, and has allowed that team to use our BVR Linux platform for their testing. And so the key things, again with the SIP stack as well, is that we do not support a particular SIP vendor. Our SIP stack is spec compliant, so we support connectivity to any SIP vendor who is also spec compliant. And we've kind of prided ourselves with the AX code as well as with the Linux code in, making sure that we fix any problems we have and are able to connect to any SIP vendor. So there's no kind of tie-in to, Cisco or Avaya. We'll work perfectly well with both of them.
Paul, question, please. What is the reason why MRCP would talk to SIP?
So MRCP version 2 uses SIP as its kind of connection layer. So when you talk to the MRCP version 2 speech server, you initiate the connection using SIP. MRCP version 1 used RTSP, I think, to set up those connections. MRCP version 2 uses SIP. So there's a connection between those two components in our code, because when we set up the MRCP connection, we use a SIP invite to set that MRCP connection up.
Thank you.
Sure, no problem. Good question. If there are no other questions, I'm going to move on to the next slide. Yeah, really this slide just kind of writes down the things I've just talked about. So it's there for reference, really. So the important things, we support any SIP vendor. We can connect to any MRCP version 2 compliant speech engine. And what else have I said there? The voice XML and CCXML browsers are reused from the AX platform, so that's proven and reliable technology. And yeah, I've highlighted that we also support full HTTP caching to kind of reduce the network bandwidth on the voice XML and CCXML resources. And then, yeah, the final slide, really, this is the final slide, is really talking about licensing. And so one of the key things we've done when we moved away from IBM and into Blueworx is introduce a slightly different licensing model for the platform. And this is still licensed by the port, or as it says there, concurrent telephone call. And so, a customer buys a certain number of port or channel licenses from us. And some key points, they're not tied to a particular server, so it's not like a server-based licensing model. We don't have to know what machine you're going to install this onto. If you buy 100 licenses from us, you don't have to put those all on one server. You can spread those over 10 servers, 100 servers if you want. The license key is tied to a particular customer, so there's no kind of sharing of the license keys. One thing I didn't put on here is that we generate these keys in-house. So when a new sale happens, come to us, we can generate the key for that sale. And there's there's a little example of a key in there. If you try and put this key onto a BVR machine, it won't work because it expired in 1977. But as it says, inside of that key is information about the customer, information about the platform that we generated the key for, how many channels that key is valid for, and also an expiry date. When we generate keys here, we can choose not to have them not expire. So we can operate in a couple of different licensing models where a customer pays for a license that only lasts for 6 months, a year, a trial license, I guess. But then we can also have a license key that never expires. And so the key things there are, if you install BVR Linux, which we're going to have some demos and some instructions about how to do that later, it comes with a license, a default license, which is valid forever, but it only allows you to use one channel. And so if you want to use more than one channel, you have to come to us and get a license. And then you take that key, you store it on the machine, and then you're licensed for however many channels we've given you.
Paul, a question, please. If you spread those licenses across, say you had 1,000 licenses, and you spread them across 250 machines, is there some way of checking across 250 machines that you haven't exceeded your license count?
So not yet. We know this is an issue, but what the solution for that is to have a licensed server, a separate machine or the same machine where you host the licenses on there. Your BVR instances come along and request them, and that's one thing that we are working on for the future. So right now, you're right. There is nothing to stop a customer installing their 100-channel license on 10 different machines and then having 1,000 channels. But we know that, and we're working toward a solution.
Yeah, there's nothing wrong with that. I just wanted to know if there was a checkout or anything like that. So there's nothing to prevent a customer from opening point.
Not yet.
Yeah, not yet. That's the key. So yeah, there will be, but there isn't yet.
Thank you.
And so that does bring up another. Well, that doesn't really bring up another point, but the other point is if anyone on the call would like to install a trial of BVR Linux, then just get in touch with us. We can certainly provide access to the code, to the documentation, and we can sort out any trial licenses for you. So yeah, that's the final slide I have. So are there any questions? or any more questions even. Okay, if not, you know, my email is on the presentation, so we'll send out all the slides at the end if Denny hasn't already, and feel free to get in touch via email to me, or if you have any questions throughout the rest of the day, just jump on the chat and ask, or just ask on the phone.
Thanks, Paul.
Sure, no problem, Dean.
Any more questions for Paul just before I move on to the next item? Okay, so the next thing we're going to talk about is some of the ways that you can deploy a BVR. Some customers prefer to have them on their own premises, some in the cloud, and there are many combinations of speech engine, application server, and so I'm just going to go through a few examples here. Again, bear with me while I switch decks. So this is the traditional model, if you like. As you can see, you have the caller on the right going through a SIP gateway across an IP network and into Blueworx IVR. Our telephony engine then calls the voice XML browser and requests the voice XML from a web application server in this case. An application server can request data from a remote source or local data, generate the voice XML, send it back to the voice browser, at which point it will connect to a speech engine using MRCP. The speech engine will generate the text-to-speech, could also provide speech recognition, and then provide the audio segments to the telephony engine to play to the caller. So this is typically what you'd use on-prem. If we look now towards a fully cloud architected solution, you can see the caller comes into to a SIP carrier. We have a couple of SIP carriers that we use at the moment. They will route that SIP traffic over an MPLS connection and into the data center. We can run on several different clouds. We've tested on SoftLayer very thoroughly. That's what we've used mainly. We're also looking to use AWS, Google Cloud, and Azure. That goes into a pool of Blueworx VMs to handle the call. The voice XML is generated by an application server pool now, again using load balancing, and we also can use a pool of speech servers, either Nuance or Lumenvox in this case. In this example, rather than just using local storage in the cloud, we have connected to a customer's data center to get application data from there. So it could be account data, for example, and the application server will connect through a VPN across the IP network to the customer's data and extract the necessary data for the applications to compile the voice XML. In this example, the customers prefer to use their own application servers as well. So the Blueworx virtual machines connect directly through a VPN to the customer's application servers, and they generate the voice XML and send the voice XML directly to us. But again, we render that and we pull the speech resources locally. Going one step further, this customers also wanted to use their own speech engine. And this is the model that we use for Watson Speech as well. Watson Speech isn't available to install locally, and so it's a cloud service. It's actually hosted on SoftLayer, so this is very quick from SoftLayer to SoftLayer. So in this example, the call comes in, it goes to the Blueworx virtual machine, which requests the voice XML through the VPN at the customer's application server. And then it generates the speech by connecting using MRCP through the VPN to the speech engine. So Watson Speech, in this case, then generates the speech, sends it back to the Blueworx VMs to play to the caller. In this example, we're using our own application server again, but maintaining the external speech engine. And this is the addition of CTI, such as Genesis or Cisco CTI. We use the customer's CTI server, and we can route the traffic to the CTI server if necessary, with a connection through the VPN to control it. So very much a quick scan through the different architectures. There are many more. I just wanted to give you an example of some of the deployments that we've tried and thought through. I'm sure there are others that you will think of. Any questions on that point at the moment?
So your previous presentation mentioned the Genesis integration for BBR Linux is planned but not current. Can you give us some kind of details on that?
Yeah, sure. We were about to commence work on that. We've sized it and scoped it and designed it. And we decided to prioritize another piece of work, which was the web portal, which talking to customers was a higher priority. And so we'll be working on the portal, the first instance of the portal first, and then CTI at the beginning of next year. So with first quarter 2017.
Okay. And then the CTI, so the current CCXML, you can't get to the CTI through the existing CCXML you already have.
No, you can't. No, the CTI support in the AIX platform, which hasn't been ported across yet, was a separate kind of component to the CCXML browser.
Yeah, there were a couple of ways on the old platform. One was the custom server, and the other was a little wonkier, and we never touched it. We just used the custom server. But okay, fair enough.
So yeah, just to cover that in a bit more detail, the custom server component has not been ported across and will not be ported across to the Linux platform. So anything that uses custom servers, it has to be written in a different way. You know, we have to code up support for that in a different way if we need on the Linux platform.
Yep.
Is CTI something that you see a strong need for?
None of our customers use an IVR without CTI. So for at least here, an IVR without CTI doesn't accomplish anything. Like the point of the IVR, you know, IVRs used to be primarily a self-service channel. These days, the amount of, self-service, if you want to do self-service, unless you're insane, you're doing it on your mobile phone or you're doing it online. You're not doing it through an IVR. So the main purpose of the IVR is to do authentication for the contact center and call routing for the contact center. You know, and the very odd, you know, there's some self-service, but it's much less than it used to be. And what that means is that the CTI is probably the most important part of the IVR. So I don't, you know, without like CTI is what's identifying the customer. Now it's possible that with SIP we could get around some of this if we're, you know, if we told our customer tomorrow that hey, AIX is gone, but the good news is your voice XML code base, because the voice XML browser on Linux is exactly the same, much of the code base can be preserved. We would then be looking at how to use, you know, some of the SIP elements to pass some components of what is done through CTI. And that's probably where the universe will end up in 2 or 5 or 10 years. I don't know. The IVRs are not a fast-moving train, or it's not an ocean. It's an ocean liner. It's not a speedboat in terms of how it changes direction. That being said, today, every IVR I'm aware of, pretty much without exception that we run uses CTI. Anyone on the call want to correct me on that one?
Was that Mark talking?
Jacob Meltzer.
Apologies, Jacob. Jacob, I mean, that's extremely useful feedback. We need to know how you're using the product, how you plan to use the product, and we reassess our priorities every 3 weeks. And so that really helps us to prioritize.
Well, now, that being said, it's not like our customers are clamoring saying, hey, we want to get off of AIX, and the thing we want to go to is BBR. You know, there's not a huge clamor for legacy code that's already out there. There's not a huge clamor to get off of the AIX platform. And if there was, typically the CTI vendor's own IVR application is top of mind. So it's not that they wouldn't consider BVR Linux. If they have to get off of AIX, they consider it, but their first choice would be, for example, if their CTI is Genesis, the first choice would be the Genesis IVR, and it'd be up to us to convince them why they would want to use BVR instead of Genesis. Okay, so I mean, I'm not saying that, you know, like it's not like they're trying to get off of AIX in the first place, by and large. But anyway, we were sort of discussing it, you know, in regards to what to do with, you know, in terms of BVR, and then certainly the lack of CTI would be a major impediment for moving the customers that I'm aware of.
But what I think I heard was though that at the end of the first quarter we should have that CTI available. Is that right, Dean?
Right.
That's exactly right, Dan.
No, and that's well within the timeline. Anyone's thinking of doing anything, so.
Yeah, if you were looking to migrate to the cloud, for example, or migrate from one IVR to another, it's not something they're going to do next week.
No, it's a 1-year project to migrate a bunch of applications. Well, the good news, it sounds like, though, is that the key point I heard is that the voice browser implementation, it's not like you even said we're going to make a similar implementation to AIX. It's you've copied the code, you're using the same code. So, I mean, because every voice XML has its own flavor. Like, one will, one won't accept certain stanzas inside an if statement, for example. Because even though the language is defined, everyone has minor interpretation differences. So it is good in terms of us knowing that we can port an application tomorrow if we needed to. If we had a pure VXML application, in theory, we could port that tomorrow.
That's absolutely true. That's exactly what we found too. Certainly on the AIX products is the way that different companies interpret the same specification. And we've always tried to work around that, rather than just saying, well, we just obey the specification, they need to do the same. We've tried to accommodate that and provide workarounds or fixes to handle those situations where a different vendor may have interpreted it differently. Again, it's around the idea that we want to help you get a working solution or help you keep your system up rather than apportioning blame.
Right. No, that's good. And then yes, not every vendor does that. Some of them sort of say, well, here's how we interpreted it, too bad. MRCP2 on AIX, the timeline for that is what again?
So the timeline for that is, I'll be honest with you, we haven't decided.
Okay.
It's going to come
The timeline is when someone yells at you saying they want it badly enough, and you'll do it, basically.
Partly that. You know, we have our own internal plans of things we're working on. You know, CTI is definitely there. MRCP is a little further out. It's in the roadmap, which actually we haven't planned to go over the roadmap presentation today. But we can, Jacob, if you'd like to, we can take you through that at some point. Which
has a better. Yeah, let's get through the rest of your agenda first, because you've got a lot of good stuff here.
Sure. And yeah, just to kind of clarify what you said, yeah, the browser, the voice XML and CCXML browsers are exactly those two browsers that are in the AIX code. So an application you wrote that runs on AIX in voice XML will run on Linux in voice XML as well.
Great.
With regards to the MRCP priority, again, we just haven't seen the demand there saying that we really must move to MRCP version 2. We decided to support that in the Linux product because that's what's current, but we haven't heard anybody saying we've got to stop using MRCP version 1.
And I mean, one push down that MRCP version 2 path might well be the integration with Watson.
Exactly. So I don't think they're doing V1, they're just going straight to V2. Correct?
Yeah, that's my understanding too.
Yeah.
Jacob, thanks so much for the feedback. Very much appreciated. So next on the agenda is going through how to install and configure BBR for Linux. For this, I'm going to hand over to Rich, who's one of our software engineers here, and he'll take you through. So just bear with me a second, Rich, and I'll hand over to you.
Thank you. Hi, so I'm Richard Lodge. I've been working for this group for about 8 years now, and I'm a software engineer. I primarily work on SIP, the MRCPv2 implementation. I've got bits of code all around the Linux product, and I also work on support for AIX as well. So I'm just going to go through the general installation and configuration for BBR7 for Linux. So the first thing I'm going to go through is just the installation part, some of the requirements that we have. The minimum requirements, I mean, you need a 64-bit, well, an x64 processor, and we say CentOS or Red Hat. The current version that we have is compiled against the 2.6.32 kernel, which means that it will work on CentOS or Red Hat 6. But I have recompiled it before for a Raspberry Pi. I managed to get, I think, a couple of hundred calls running into that concurrently, which we were pretty pleased by. We've designed this so that it's nice and quick and easy to install. You can, it's not a particularly heavyweight install and setup process. The idea was that you could just get the RPM, install it, and it would pretty much work straight away. So, I mean, I've had it set up before once the RPM's on the system, I've had it set up before in less than a minute, and you can just make a call straight into the sample application. Now, there's no software prerequisites when you install the RPM. I've installed it before on minimal CentOS installs, which is, it's come with as little software as possible, and the JRE is included in the RPM. So when you install it, it kind of ensures that it's nice and easy to install, but it's also consistent. You're always going to get the same JVM. So it just makes it more reliable. And the installation is a pretty simple RPM command, RPM-I, and then the path to the RPM. After that, you just have to log out and then log back in again, because it sets up some environment variables, which make life a little bit easier once it's started running, and you also need that to run the main BBR command. So I'll just talk a little bit about the file structure that we have. Now, the first thing to point out is that we detect the host name of the system, and we use that for some of the file paths. So, for example, the config is stored in a directory that's named after the host name under the config directory. It was done this way for future proofing, for future kind of SSI type setups. Now, obviously, what we've done is we've set up a load of path shortcuts to this, environment variables. It just makes life a little bit easier when you're trying to remember the host name of the system you're on. They're pretty obvious ones. BBR home is the standard install directory. The conf takes you straight to the config directory, and same with the logs. So the config and the logs are both under host name path, because they're things that will be individual to a specific system, whereas other things might be shared between systems. The bin directory is where the JRE is stored and all of the code. So there's the main BBR jar, which contains most of the implementation. That includes all of the MRCP, the SIP, and everything to do with the config. But we do have some C code. As mentioned before, the DTNA, which is the streaming module, is a kernel module, and the license code is in C, as is the DTMF grammar compiler. So we also have the resource directory. This is where all of the cache goes, and the license directory, which is where you're going to put your key file when you get that. So I'll go through a quick overview of the config. As mentioned before, the configuration is a flat text file. It's nice and easy we've made it so that it's easy enough to read and change. And as I said before, the defaults in it are all set up so that you can just install it and run it right away with no issues. So it's in the VBR conf directory. Now, we provide a sample config, and the whole of the config is self-documenting, which means that it's got plenty of comments in it. It describes everything that you can configure. And so just looking at the config file will make it pretty self-explanatory. Now, it's in a format called TOML, and I'll explain, well, what this looks like next. So it's pretty standard for some config files. Anything after a hash is ignored. I think you call that pound, actually. Anything after a pound is ignored. And the config is broken up into sections. So you've got anything in single square brackets is a section that can only appear once. So, for example, general parameters, SIP parameters, the streaming engine config. But you do get some in double brackets, which means that they're an array, so they can appear multiple times. For example, you'll have that for your app mappings, which maps the user part of a SIP URI to a voice XML or CCXML application. So they need to appear multiple times. Some of these sections have subsections. So an obvious one is MRCP with a TTS subsection, and MRCP resource with also with a TTS and also a reco subsection. This is just to help categorize all of the settings. So the variables are pretty standard key value pairs. If it's a string, you put it in double quotes. If it's a Boolean or any kind of number, you don't put any quotes around it. So here's just an example of what the general part of our config file looks like. So, I mean, I can go through some of these. So the Java command is the Java command that actually runs VBR Linux. So it means that you can add extra parameters to it if you need to supply them, like this max memory 256 parameter. Or you might want it for if you're doing anything to monitor your JVM. Occasionally that needs some extra parameters in order to hook into it. You can set a class path for additional jars. This is useful for if we provide an ifix to somebody, they can just put that in the class path variable in the config file. You can set a maximum call capacity. Obviously, this doesn't let you go anywhere beyond your license, and currently the maximum for that is 500. But as mentioned before, we will be looking to increase that at some point. There's also this default bind address. Now anything that goes over IP needs to bind to a local IP address, and the default bind address option here provides the default for all of those components. So, for example, for SIP or for MRCPv2 messages or for RTP streams. So this is a useful setting to have because on some systems you might have multiple adapters, or on some systems it's just not possible to detect what your local IP address is. Or sometimes it detects your local address but not your public address. So this is your kind of default bind address, and you do need to set that up on some systems. We also have this concept of a presentation address, which is different for different things. It mostly affects how we present what our own IP address is. So, for example, if you set it for the streaming section, it's in the SIP SDP, it's going to say what our IP address is according to the presentation address. This helps overcome some potential NAT issues that you might see. Now, I will go into some more detail about some of the other config options in a bit. So I'm just going to do a brief overview of the speech services and MRCPv2, what MRCPv2 is. So I'm sure you know about MRCP. MRCPv2 is a newer version of it that uses SIP for setup and teardown of MRCPv2 sessions. Now, it's actually incredibly similar to MRCP once you get down to the actual messages. So we support anything that's MRCP v2 compliant, such as Nuance and Lumenbox, and we are Lumenbox certified. Now, if you want to look up more about MRCP v2, just look up RFC 6787 if you really want to get into the detail of it. But the main thing that you need to know is that we'll work with anything that's MRCP v2 compliant. So what the SIP does is it sets up the TCP session for the MRCP v2 messages, and also the RTP streams for the audio that's going to the MRCP v2 server and from. So, you know, the TTS and Reco audio. So internally, our product treats TTS and Reco sessions as if they're calls. So that's just the way that the code works, but these don't count towards your license usage. So, for example, if you have a call that has a TTS and a Reco session, that call is only using one channel in your license. It's not using three. So that's an important thing to know. So they're both treated as separate MRCP v2 sessions. It is possible, according to the spec, to be able to have both TTS and Reco in a single MRCP v2 session, but that's not the way that we have implemented it. So you have a separate TTS and Reco session. And they're identified by a channel ID, which is effectively the equivalent of a call ID or any kind of session identifier. And that channel ID appears in the SDP on the initial setup, and then it appears as the channel identifier header on MRCP v2 messages. Now, there are two sections in the config that affect MRCP. The MRCP section is mostly just default settings, and also the bind address for the MRCP v2 messages. Now, you might want this to be different to some of your other ones, because a lot of the time your MRCP server is on the same network, and so you might want to set that as a local IP address so that external things can't connect to it. And then we have the MRCP resource. So this is effectively a definition of an MRCP server. And I'll go into a bit more detail about some of the options on that on the next slide. So MRCP, we've got bind address, which I explained earlier. The presentation address is the address that we present ourselves with, as in the SDP. There's a session initiation timeout. So it's not often that this will come into effect, but occasionally you might send a SIP message to the MRCP server. It'll respond with a 100 response, and then it won't ever give you anything again. And you want to make sure that that doesn't leave you with a load of sessions that just aren't doing anything. So this just allows you to configure that timeout. We've also got TTS and Reco subsections. So keep session is the thing which says it's defaulted to true, and this will keep the TTS session for the duration of an entire call. Now, you can set this to off, and that's particularly useful if, for example, you do one bit of TTS in a call, and it's a very small part of the call. And the reason for this is that it helps with people that have a limited amount of licenses for TTS on their MRCP server. And in Reco, we have a DTMF recognition option. Now, by default, I believe this is off, because usually we use our own internal DTMF grammar compiler. That's the quickest and the most efficient way to do it, and it's not necessary to use up Reco resources for it. But if you want to, you can get your MRCP server to do DTMF recognition. So an MRCP resource, it has a name. This parameter isn't actually used anywhere. It's cosmetic. It's just for your own reference. And then there's the SIP URI, which is the SIP URI of the MRCP v2 server. It's just a standard SIP URI, SIP colon, Lumenbox, whatever the address is. A locale. Now, the locale is a regex string. The reason for this is that you might have a TTS or ASR server that supports multiple so multiple kind of versions of English. So, you might have ENGB or ENUS. So this is a regex string. It just means that you can do en.star, and it will connect to that MRCP v2 server for for everything that's EN, so everything that's English. Now, we've got subsections for this. You can enable or disable TTS and Reco. The reason you might do this is you might have one server that you'd rather use for TTS and one that you'd rather use for Reco. So you can supply that twice. And the keep session and DTMF recognition in those subsections, they override the default one supplied in the MRCP section on a per resource basis. So I'll just go through some of the initial setup steps that you'll need to do. Now, really, on most systems, you can install it and start it, accept the license, and it'll just work. But it's worth checking for a few things before that happens. So the first thing to do is, well, once you've installed it with with RPM minus I, once you've installed it, is to set up your license. Obviously, if you have a license, you want that to go straight to the license key file, because otherwise you'll only be able to make one call. It just seems like PowerPoint has automatically capitalized the echo, so obviously don't copy-paste that command. So if you have a license key, put it straight into the file. If not, no action is required. I think BVR lets you make 2 concurrent calls, or is it 1?
I think it's actually 2, which allows you to do a call transfer.
Yes, that was it. So it's 2 concurrent calls. Really, the most important thing here is that you check the IP address settings. So on some systems, I've seen it on some VMs, you can't set up. Well, it doesn't detect its own IP address. So it's always good to explicitly define the IP address in the config. And the easiest way to do this is just to go into the general section and set the default bind address, because that'll set it for everything. And you should have no issues after that. But you can override it for each different section if you feel like you need to. So the next step is to set up your firewall. I'm not going to go telling people how to set up their firewall. That's up to each individual implementation. But you have to make sure that the SIP, whichever SIP ports are configured, are open, as well as whichever ports you're using for RTP for voice calls, RTP for MRCPv2 sessions, and MRCPv2 messages. Now, by default, we use ephemeral ports, but you can configure this with the port range setting. So there's a port ranges section, and you can just do a general port range. You can say where the port range starts and the port range ends, and that applies to calls, MRCPv2 calls, and messages, as I described earlier. But you can set them individually. Anything that's not set individually will use ephemeral ports. So starting BVR is pretty simple. You run BVR-test, and that will start it. Now, the first time you run it, the license will come up, and you just page down to the bottom of that and accept it. Well, obviously read it first, but page down to the bottom of that and accept it. Now, BVR won't start if there's issues with your config, and it will explicitly tell you what the problem is. For example, if you've mistyped something, it will say, there's a problem on this line of your config, you've typed this, and you need to correct it. So any problems that come on startup are usually fairly obvious. So now that it's running, you can make a test call. We have some default app mappings in there for 1001 or sample, and that just points to a sample application on the local file system that just says welcome. But it's a good way to test that your system is up and running. So you can put your soft phone directly at the system, as I've shown in the slide. So if it's successful, you'll just hear that voice prompt. So in summary, it's quick and easy to install, self-documented configuration, we supply you with a basic config, and a simple sample application is supplied. That's a bit of alliteration there. Now I'm going to go into a little bit of detail about some more of the specific config sections. Do people want me to go into more detail about the specific config sections, or I can skip this if If there's no comment, I'll just carry on and go into detail. I shall carry on. So I've already mentioned the general config, so I'll skip this bit. So this is how app mappings work. The app mapping has a user which maps an application to the SIP URI, to the user part of the SIP URI. Now, that is a regex string, which means that you can have multiple different paths to the same application. For example, it's a lot easier to reference an application by its text name, for example, sample. So in the sample application, we've supplied 1001 or sample because some SIP phones don't let you use don't let you use text. And you also might just want to have multiple routes to it. The type of application, so that's pretty simple, that's CC XML or voice XML, and the URL, which is the fully qualified URL to the application. So that's just what it looks like in the sample config file. SIP config. So bind address I've already mentioned, and a presentation address I've already mentioned as well. Headers to capture. This is where you can supply a list of headers in SIP that you wish to capture and send to the application, so to the voice XML or CC XML application. So I've just put to and from here because that's the default, but there are often vendor-specific parameters like X user to user, etc., that you might want to pass. And so this will just automatically pass it up to the application. You can also configure listening points. So in most cases, you don't need to set this. 50/60 is the standard for SIP, but you can set different listening points for different protocols if you want to. We've also got config for SIP proxies. So you just supply the address, the port, the transport, and extra params. This just adds the extra params to the SIP URI. Generally, I don't think most people will use this, but it gives you that extra flexibility if you really want to. Try anonymous is if you get a authentication challenge, you do have the option of being able to try using an anonymous user when you're using a SIP proxy. So by default, that's false, but we have given you that option in case you do want to try anonymous with user proxy. It's not going to the next one. Okay. So the SIP proxy credentials. These are kind of they're not tied to a specific proxy. It's all based on the realm that you use. So different proxies will ask you for credentials for different realms. So you need to know the realm, the user, and the password. Now, you don't have to supply the password. We've made it so that you can also supply the HA1, the hash of the A1. It just means that you don't have to store your password in plain text. And if you do try and start BVR with the user and password, then we will tell you what config line to put into your config to use the user realm and pass hash, because it's just safer to do that. You can also decide what your preferred quality of protection is when you're using a proxy. Some things we use auth and some things we use auth in. And sometimes they'll give you an option of multiple. So this just says which one we prefer to use. The FCP config is all about hold, really. We may have further options for this in the future, but this is about the hold method that you use. The default is RFC 3264, where you do send only, send receive, and etc. And that's just because that's the current standard. But we do support the legacy method for interconnection with any older systems. Streaming config just says whether or not we will accept RFC 2833 DTMS. This is true by default because most people wouldn't disable that, but we do have that option if you need to. And the RTCP sender is just how frequently we send RTCP packets. And I've already gone into detail, as I've mentioned before, about the bind address and the presentation address. And that's just a further reference if you want to look at those slides at another point.
Okay, so next item on the agenda is the problem determination, and for this, Rich again is going to help us out. So I'll pass you over, Rich. Let me just hand control over to you.
There we go. Right, so I'm going to go through some problem determination stuff. If anybody has any questions, please feel free to interrupt me on the call, and I'll answer them as best I can. So, yeah, this is how you go about determining problems within BVR for Linux. So, firstly, I'll just give a quick overview of logging and tracing. So, the tracing works. We put our logging and tracing into the BVR logs directory, as I've mentioned previously. And we designed it so that you could do some more targeted problem diagnosis. A lot of things seem to have a concept of a trace level, but as there are so many components in BVR Linux, we wanted to be able to narrow it down to specific areas of the product. So for example, there's a SIP component, there's an MRCP component. So if you know that your problem is occurring in SIP, then you just set the SIP component's trace level to something higher, such as debug. And you can set these in the config file, but there is also a command so that you can change the tracing and logging levels on the fly. Otherwise, of course, customers would have to shut down their system if we asked them to get more trace, which would cause some problems. So there are 4 types of files related to problem diagnosis. There's the error files, which is where all the errors and warnings go, and they just go straight in there. These files are usually, they wrap around like the trace and log files do, but you'd have to get a lot of errors for them to wrap around. So there's the log files. This is entirely for application logging. So if you've written an application with log tags, then they'll go out into the log file. And trace is for targeted problem diagnosis, really. Or you can get everything to go in there if you want to. And this will give you a lot of detail about what's going on. There's also just a standard out file called bvr.out. Nothing really goes in here. It's just where stuff from startup goes. But it's there if you need it. So each file has a number. It starts with 0, and when that file is full, it gets moved and becomes 1. So it means that the file with the latest bit of trace in it is always the 0 file. It just means that you always know which thing to tail if you're trying to monitor it live. So that's how the trace files work. So when you look in the trace files, you'll see a trace line with a format like this. So we give you the date and time, the call ID, which is specific to BVR, and it's kind of an index, and it increments by 1 each time there is a new call. Now the call ID is prepended by a letter determining what type of call it is. So for standard voice calls, we have BC. If it's, as I mentioned before, MRCPs, TTS, and RECO are counted as if they are calls. So if it's a RECO call, it will be RC, and if it's a TTS call, it will be TC. It just allows you to see better exactly what that call is supposed to be doing. The component is the component that it comes under, so SIP or MRCP or call. The thread is the thread ID and the thread name. The trace ID is a trace ID that is unique for that specific trace line. And that's mostly for our purposes. It allows us to be able to find that specific point in the code very easily. We also have just the text describing what's happening. So we've tried to make our trace lines as readable as possible and give you as much useful information as you can. So a lot of it is written in plain English, especially for a lot of the error or warning situations. So an example trace line is this one. So what's happened here is, I realise that that's a bit small. Hopefully everybody can see that. So what's happened here is the connection to a nuance server has gone down. So there was a timeout, and I've written in plain text why that's happened. So we sent an invite request, we got a 100 response, but we never got anything after that. So I'm trying to make it as obvious possible. And because this is a warning, this will go into the error file, which is a good file to monitor periodically, regardless of whether or not you're noticing any problems, because it will tell you if there's things wrong in your environment or anything else. So, as I said, I've tried to make them as readable as possible. These are the trace levels that we have. So they are cumulative. So each one down the list includes all of the previous ones, and the trace levels only really applies to the trace file. That's the main thing you need to worry about here. So off obviously sets all the trace off for that particular component. Error is a serious problem. So it's usually something that's within our control, but it's gone wrong. So hopefully you shouldn't see any of these. Although occasionally errors will pop up for other things. So for example, as I mentioned before, if your config is wrong, we'll raise it as an error. The warning is something that will probably affect an individual call, or it's a problem that's external to BVR in the first place, as like my example earlier, where you can't reach the MRC. Info doesn't show up very much, but it flags important info that usually shows up on startup. Log is entirely used for application logging. In fact, I think you can ignore that trace component. Oh no, you can put log into the trace, so app logging, which might be useful for some people. Trace, this is where it gets more tracey. You get more general information about what's happening on every single call. This will trace out a load of information, and it will show you the basic information of the call's progress. Debug is just a more in-depth version of trace, and anytime you get a problem, it's recommended that you set at least debug for that specific trace component that the problem occurred under. Entry and exit is entry and exit of methods, so that's a little bit more intensive than debug. And then we have this concept of intensive. Now that is for things that really are quite intensive to trace out. For example, SIP messages. If you've got 480 or 500 concurrent, 500 concurrent calls, you don't want, in most cases, you don't want all of the SIP messages being traced out. It's very I/O intensive, and it's going to fill up your trace files and cause them to wrap very quickly. But sometimes it's useful to set this if you know that the problem can be solved by looking specifically at the SIP messages or the MRCP messages. So the config for trace is fairly simple. You've got the trace section is kind of the default, has the default trace level. So this is the trace level that it will set to pretty much every component when you start up. The file count is how many files you go through before it wraps. The file limit is how many megabytes each file can be. And file append, do you want to explain that one?
It's whether you need to start a new file and start up when you start up BVR again.
Okay.
So if you've got that set to false, it would create a new set of files.
Yeah. Okay. So, and then we've got the component trace level. So this will set the trace level for an individual component. So, for example, here we've got SIF and trace. Or you might want to do MRCP stack and intensive if you want to see all the MRCP messages. So we've got some command-based monitoring tools that I'm going to go into. So there's the BVR command, which is just the standard command. This is the thing which we use to start up BVR in the first place. So BVR-S starts up BVR. Actually, one thing that I didn't mention is that BVR-Q shuts it down, quiesces it. BVR-M will give you effectively a snapshot of the overall picture of what's going on. So it'll give you, for example, the total number of calls that have been made on the system, how many SIP calls there are, and how many voice applications there are. We've also got a few useful things like used memory, the number of threads being used, and how many channels, how many RTP channels there currently are. So there's usually a little bit of difference between the number of active SIP calls and the number of voice channels, because there was a very short period between the setup of the signaling and the starting of the streaming, and that's more noticeable on tests where you have very short calls. Then we have the counter of the warnings and the errors, which is pretty useful. Now you can get this to refresh every so often. So BBR-M2 will refresh this display every couple of seconds if you're actively monitoring the system. So we have this concept of reports, and what this does is it gives you a snapshot of every single call on the system, and it generates 3 files. There's the call status, which is every single call that we have and which text-to-speech and record calls are associated with those calls, if they have any. And then there's SIP status, which gives you every single call ID. Generally, this will be quite a long list if you're using MRCP, because if you've got 500 calls, you could end up with 1,500 SIP sessions, because you've got one for the call, one for the TTS, and one for the echo. These all also give you the call ID, so you can look at one file and you can easily tell which things associate to which. So you can find the SIP call ID just by looking at an internal BBR call ID within that file. There's also the voice app status, which just gives you every single voice app that's currently running. Now, both the SIP status and the voice app status have an internal FSM status. It's just about the state machines that we have. It's mostly useful for us, helps us with problem determination, because we can tell what state each individual call is in. Now, we also have a live SIP message monitor. This is separate to the trace. So you can run BVR-SM, and it will output every single SIP message to standard out. Now, you can do what you want with this. Obviously, you could pipe it to, you can redirect it to a file, future reference. You can get it to come out in trace as well, but this is useful if you're just want simple live monitor of all the SIP messages that are going through. And BVR-T allows you to set the individual trace levels. So it does the same as what the config did, but you can do it while the system's live. Now, this doesn't persist after you've restarted BVR, because the whole point is that it's just active for a live system, and if a customer has a problem, we will ask them to set the trace levels for the component that we believe the problem to be in with a simple command, and they can then get the trace for us and send it to us, and it's nice and easy. Now, this isn't anything to do with BVR Linux specifically, but it's a very useful tool that we use all the time. It's TCP dump, and it's on most Linux systems. It'll monitor all the network communications, and then you can analyze it in Wireshark. Now, we find this useful, obviously, for viewing the contents of packets, and you can see exactly what has been sent to the system, rather than how that packet has been interpreted. So it makes it very easy to see if there's anything malformed in a packet. But you can also, it has some extra tooling specifically for RTP streams. You can reconstruct the entire RTP stream, and you can see what was sent to BVR, what BVR then sent out to the MRCP server. And like I say, we use this all the time, and that command is how you run it.
Rich, it's probably also worth pointing out that many of these facilities will be available over a web interface, which is currently in development. We target delivering that early next year, but at the moment, this is a very clean and efficient way of monitoring the system.
Yeah. I won't repeat you because you just said it. So I'm just going to go through the problem determination route that you might go through if you're experiencing any issues. So if you've got issues starting BVR Linux, it's going to be pretty obvious. It'll write it to standard out and BVR won't start. So usually things like this, they're going to be related to the config file. Something might have been put in wrong. So I've given some example output here. Obviously, I've put an extra R in true, and that isn't a proper Boolean value. There's no such thing as true. So it's saying that there's an error there, and you have to correct that. That's pretty obvious, and that's going to be the problem that most people experience straight away if they have any issues. If you have any issues with your applications, then you just check in the log. As long as you've put log tags into your application, which we recommend you do anyway, straight out into the log file. If you're getting other general issues, the next place to look is always the error file. Like I've said before, the text from these is designed to be as human readable as possible to make it obvious what the problem is. So I've already gone through what this specific trace line is. So if the problem isn't obvious, this is when you have to get into the trace file. So you know you need more detail, and you need to really it's best to set everything to at least trace at this point, because while a problem might appear to occur in a certain component, it's possible that it'll appear elsewhere. Oh shoot, is that the fire alarm? It's possible that it'll appear elsewhere. So it's always best to set everything to at least trace, and the component that you believe the problem appears in, it's always best to set that to at least debug. But if you know it's a problem with SIP messages, set it to intensive. Especially if you can easily replicate the problem. If you can easily replicate the problem with a single call, and there's no other calls running into the system, there's no harm in setting everything to intensive, because that's going to give everybody as much information as possible, especially us. So you need to raise a ticket, then we have a command called BVR problem, and it gathers a load of information about the system. So details about the machine, the disk, the network, and then some BVR specific things. So it'll give you all of the trace and log files, and it just packages all of that up into a compressed tar file, so that it's nice and easy. You just have to run that and then send it to us, and then we can look through, rather than having to run a load of separate commands to gather all the data that you need. So you just run this with BVR problem and then the output directory, so maybe /temp, and then it will prompt you a few questions. If you have a ticket, for example, it'll ask you if you have a ticket open, for example, and then it will put the ticket name into the file name and everything. So it's best to run this while BVR is still active. You'll get the most information out of it that way, especially because it does things like generate the reports that I mentioned earlier, like the SIP status. And that's particularly useful sometimes because it allows you to tell whether or not some very old calls are hanging around, for example, are hung up. So this will give you all the information. And I believe that is the end of the problem determination. If anybody has any questions, then feel free to ask. Otherwise, I'll on to the next.
Yeah, so I guess, are there any questions around problem determination, tracing, and things like that? We plan in the demo section of the day to kind of go through some of that to enable trace, take a look at some error logs and things like that. So we're going to cover this again later on. But if there are any questions right now, please let us know.
Okay, so we'll now move on to application development. For this, I'm going to hand over to Shahab Rostami, who is one of our software engineers. So, Shabs, as we like to call him, I'll just hand over to you.
And do I just share the application? Hey guys, so this is Shahab Rostami speaking. As Dean said, that usually gets shorthand to Shabs. And I've got some demos later as well, and you might see a reason why I do shorthand that to Shabs. It seems some MRCP engines struggle with the pronunciation of Shahab. Anyway, I was lucky enough to join this team around 2.5 years ago, and that was just before the Linux initiative. So that means I was quite involved with some of the main components of the Linux code. That includes things like the VXML session, the internal DTMF compiler, the commands and tracing, along with some of the core classes. I also do have a helping hand with the AX support, along with some Watson testing. So I believe that some of the MLC connects the team on the call, and I believe I've worked with them quite often. So I'll be going over the VXML and CCXML application development in BVR. Now, I'd like to approach this topic by assuming an application developer role. I'm going over the major differences to expect when developing an application for BVR. I thought this might be a bit more useful when going through the spec and ticking everything off one by one. So there might be quite a lot of content. I'll be going over what BVR does differently, both in VXML and CCXML. So that's what we've added or what we currently don't support. Then continuing on to some detail on some of the key functionality. So, first of all, VXML. As mentioned in the previous presentations, the VXML interpreter we use is built on the interpreter that is used in BBR on AIX. We've ported and reused this component into our Linux platform. You will likely hear this reference as VXI. This passes and interprets the VXML applications as you'd expect, and as it's reused from our AIX platform, it's been used for quite a long time. I think Paul mentioned around 10 years, giving us an extensively tested, stable, and reliable interpreter to build our VXML layer on. So, BVR supports both VXML2 and 2.1 applications. And just as a side note, because we've seen this in some other platforms, any application that has been built against a certain level of VXML will need to specify the correct version in the VXML tag. So, for example, if you use console transfer, which was added in VXML 2.1, you will need to specify the version as 2.1 as you'd expect. So to go over the main differences, even though we support both specifications, we've built on it slightly. So the arbitrary SIP headers, both inbound and outbound. So the BVR APIs for CCXML and VXML can be used to specify and extract headers and header data that are sent in SIP messages. That might sound a bit confusing, but I'll be going into further detail on this in the next couple of slides. Going on from this, the extended site documents. This gives extra optional functionality on top of the spec recommended behavior. Things such as several functions for the previously aforementioned arbitrary SIP headers, and also provides extra audio and TTS in various locales such as English, Spanish, Italian, Japanese, Korean, and so on. We've also added support, as mentioned again in everyone's slides, about the Watson's TTS and STT. So in particular, we've added support for the SSML tags for synthesizing text using various styles through their express as tag. With this, the application developer can set the tags that come with the Watson TTS service into their prompts, allowing you to indicate expressiveness in a variety of speaking styles, such as apology, uncertainty, and I believe good news, which could be useful. Other than that, the last one in terms of differences is the mark time and mark name property. Now, this is quite a small part of the spec, but we've extended it to make it a bit more powerful. These properties can be used to help pinpoint barging detection during prompt playback, and this is what the spec is recommended to do. So, mark name provides the name of the last executed mark before barging occurred or the end of audio playback. And mark time, as some of you may know, is the number of milliseconds that has elapsed since the last mark was executed. So as I said, the spec only requires this to be set for audio output, but we've added the option for this tag to be applicable. I don't know what happened there. To be applicable in other tags as well throughout the VXML application, regardless of barging, such as TTS, RUCO, and transfer, and so on. So those are the things that differ from the spec, and these are the things that we currently don't support. The field support within the transfer tag, for example, prompting during a transfer being invoked. This is not technically required by the VXML 2.1 spec, but is just worth mentioning. Some of the transfer attributes, such as connect timeout, max time, and transfer audio, along with the final silence attribute of record. I'll be going over the application logging, reporting, and monitoring in VXML in some of the demonstrations later. Any questions on VXML at all? Okay, on to CCXML. So, as many have said before, similar to VXML, we also have ported and reused the CCXML interpreter into our Linux platform, providing a similar level of reliability and stability. We support the CCXML1 spec fully, with a few additions. Fully in comparison to our BVR AX spec, I should say. Again, arbitrary SIP headers, as mentioned before, this is supported on both the VXML and CCXML layer. Again, I'll be explaining this next. Other than this, we support the basic HTTP outbound messages and create session processing. This is referenced as Appendix K and L in the CCXML1 spec if you want a great deal of detail, but I'll just go over it briefly now. Basic HTTP inbound is required by the spec, but we also support the outbound HTTP messages via the send element. This basically allows CCXML documents to make a HTTP request to somewhere, for example, a monitoring server with an open HTTP server. So, using both inbound and outbound messages, you could use another server to drive the current way your CCXML document behaves. For example, setting up a variable that other transitions in your document examine into. So just as a brief example, you can start different voice XML documents depending on the value that was set in these HTTP messages. And create session allows the user to send HTTP messages to make a new session entirely, passing the URL and optionally other parameters such as timeouts. So a session in this scenario is equivalent to what we see as a thread that has been set to handle events of that particular CCXML application. Now, another big difference that we've got in our CCXML layer is the ability to specify whether you would like a multi-call or a single call mode for that particular application. I'll also expand on this further after the arbitrary SIP headers. Lastly, to trigger a transfer, this isn't directly specified in the spec, but the way we do it in BVR Linux is by specifying the transition events of BVR consult transfer and BVR transfer, invoking a blind or consult transfer as you would expect in C6ML. So, currently not supported, and this is similar to our BVR AX product, redirect, conference, join and unjoin, and merge, along with the attribute prefix on the send. We've also, as mentioned in Rich's presentation, that we've implemented application logging and call trace for the CCXML component, including current active CCXML application status reporting and other stats, etc. So, before I go into more detail on arbitrary SIP headers, is there any questions on CCXML that I've covered just now? Splendid. Onto the SIP arbitrary headers. Now, this is quite a big feature that we've added. The best way to explain this, I think, is to just go through an example. But firstly, just a bit of an overview. As I said, it's in both our VXML and CCXML APIs, so you can specify headers and their associated values from the following SIP messages. This includes inbound and outbound call, the invite request, transfer, the refer request, and near and disconnect, the buy request. So for these to actually be accepted and passed into our BVR application layer, you would need to set these headers in the BVR config file, the one that Rich mentioned. I'll also go over how we do this in our example. So to use arbitrary SIP headers, there's basically two mechanisms as they're both applicable in VXML and CCXML, depending on whether you use CCXML and VXML together or VXML on its own. The following example, just for simplicity's sake, is with the latter, VXML. So here we can see an inbound call's initial invite request into BVR, displaying the arbitrary SIP headers under X user to user and X checksum. Nicely pointed out by the big arrow. So as I mentioned, the way to do this in BVR config to accept these parameters above is to specify them in the headers to capture attribute within SIP. Makes it quite easy. It's not that you'll get any warning or error if you don't set them, it's just that they won't be passed onto the application layer. So as I said, the site documentation that's been extended has given us a few extra functions to use within our application layer. The getInbound header function allows the application developer to extract the particular header's value. So as we saw in the previous slide, the X user to user header and header value was present. We can set this into a variable named here used to user using VXML, and then do whatever we want with it. So in this case, I've given a quite abstract function of update user header, just for simplicity. You can let your imagination decide what happens to that. But this function will use the user variable in some way, updating the supplied header value that was passed into from the initial invite request. So after we've updated it, we can now set the outbound arbitrary SIP header into any following SIP request. So you can see here the two functions again I've used are the set outbound header, with the header name and the value. So here you can see, as I've not changed the X checksum value, I've simply just passed the value from the get inbound function header back into the header, but updated the X user header with the new we've got. Now, the example here I've used to demonstrate how this has been passed on is the refer request. So I'm guessing I'm doing a transfer here. Well, I'm not guessing, I know. And you can see it's been placed under the X user to user header with that new value. You can take my word for it, but you can see it starts at 9, but 4 there. So as I said, the site docs also provide some other functions, which are the print object, which prints out the attributes and its associated values of a JavaScript object into a string and returns it. I'll just put an example there of how you might log the inbound headers with one log statement. The clear outbound headers removes all values from the outbound array. This will stop them being used on any subsequent VXML transfers and disconnects for the same call. So, do you mind if I interrupt a bit, Shams, to talk about why we do it?
Yeah,
you go.
So I just wanted to kind of highlight this. So we've already discussed the kind of lack of CTI support at the moment, but what the arbitrary SIP header support can do is allow you to do a bit of that CTI functionality by taking information from the inbound call, from the invite message in the inbound call, and then updating that by whatever your application does, and pushing it out on the transfer to your agent, say. So it kind of it gets around a few of the issues you might have by not having CTI support, kind of I guess native CTI support in the platform, and it allows you to do some special things that particular SIP vendors might make use of.
So you can use this SIP capability to potentially eliminate the additional costs associated with a CTI product to perform stream pops and voice data transfers.
There's the potential for doing that for sure, yeah. Obviously all the other SIP endpoints in your network need to also make use of this functionality and be able to add things into the SIP messages and extract from the SIP messages. But our platform provides the ability for us to do that, for us to take things out of the SIP message and add things back in again. And so, assuming the rest of the network also does that, then yeah, you as you say, you can get around that, as potential cost of a CTI solution. And this is not unique to the Linux platform. This functionality also exists in the BVR AIX platform too.
Great, thank you, Paul. Are there any other questions on the arbitrary SIP header section before I continue? Obviously, if you'd like some more information on how we would do this in CCXML with VXML, we can go back into more detail later.
Yeah, so Shabs, let's go and interrupt again. So the way you do this in CCXML is very similar, right?
Yeah, very similar.
We also provided methods that allow you to extract those SIP headers into your CCXML application, and then you can populate them before you do a transfer if the transfer is initiated from CCXML rather than voice XML.
Yep, there's not many major differences. You just do the CCXML markup instead.
Okay, thanks, Shaf.
Cool.
And sorry for interrupting.
No worries. Any more questions, Paul?
No.
I'm joking. So, on to the second kind of key difference between how we handle the CCXML layer. That is the single mode and multi-mode for CCXML applications. Just as an overall summary, this is just the way we route calls into BVR, into the CCXML layer. You can set this in the BVR config, so you can set whether you'd want single mode or multi-mode on a global level or a per-app basis. To go over what they actually are, in a single call mode, the BVR system launches a separate CCXML browser for each new call that is received. So something to keep in mind, in this mode, the initial CCXML document can be written with the assumption that global variables will be unique for each call, simply because the document will initially only execute for events that are caused by a single connection. So if you were developing an application that you'd want to be in a single call mode, you could potentially make it a bit easier for yourself. In the multi-call mode, a single CCXML session handles the events from multiple connections. So before I go into more detail on that as well, I've kindly taken Paul's diagram. So here we've abstracted the CCXML and core processing layers. So for me to explain a bit more about the application infrastructure, we're going to delve deeper into those two components. So there's a lot of arrows, but they all make sense, I promise. The CCXML layer has its separation between the single mode and multi-mode components. So on a single mode basis, you can set a particular application to always be created with a new session. So any new call that comes in can be handled in a kind of secure and contained session in CCXML. And you'd only ever get one call for this single mode session. So you can assume when a single call mode call is completed, the exit tag should be used to end the call and free the memory. And in a multi-call mode, a single CCXML browser session, as I said, handles events from multiple connections. So you can see here the bottom multi-mode component is handling 2 calls. And this, as I said, kind of relevant to the single call mode, you can assume that the variables are global by transition when operating in this mode. So you want to make sure there's no unintentional modification of the global variables. Again, in a multi-call mode, similar to the single call mode, you don't really want to use the exit tag at all, as this wouldn't just end the call, it would end the session that it's contained with. And that would kind of make it difficult for all furthering calls within that call session. Paul?
I just wanted to pick up on Shab's point there. The two important things to remember are when writing CCXML, if you use single call mode, you need to use the exit tag.
Yeah.
And you need to exit that CCXML, otherwise it hangs around after the call is finished. And in multi-call mode, you don't ever want to use the exit tag, otherwise you're essentially destroying any other calls that CCXML browser is handling at the time.
Yeah. So if the browsers were to exit at the end of each call on a multi-call mode, the amount of browsers would, for one, decrease each time for available calls, and if it was only just one for that particular application, there would be none left. So
I understand that's all in the application. Is there a benefit of using single mode versus multi-mode?
It's in particular for the single call mode.
Yeah.
We've done it this way. So for things when you use the HTTP messages, we would initiate a single call mode CCXML session just for that call, which helps it be a bit more contained rather than mapping it to this bigger container with other calls.
Yeah, and it also, as Shab's kind of mentioned, it makes it easier as far as the application variables in the CCXML. They're only associated with that one call. So in some ways, yes, the single call is kind of easier to kind of understand how it behaves and how what you do in the application affects only the one call. But multi-call has its benefits too.
Enterprise level, especially.
Yeah, but a multi-call browser makes a lot less use of the BVR's resources because we're only running one application rather than 500 on the 500 call system. Yeah. But as far as the application developer is concerned, single call is a bit easier to get your head around how you code one of those up.
Okay, thank you.
So we support them both, and as Shab's kind of alluded to, I think he's going to show you in his demos. You can configure the system to use both. You can have a particular number that goes to a multi-call CCXML, and then another set of numbers that goes to single-call CCXML. So you can do both. You can do them both at the same time. You can complicate this as much as you like.
There's a good question there from Mark, which is, are session variables shared in multi-call?
Yes, they are.
Yeah, on a global variable. Yeah.
Yes, they are. So, if you want to associate them to a particular call, there's a unique call ID for each of the calls that the multi-mode browser is handling. And so you can kind of get over that situation and have a variable that is only associated with one of the calls. And I think we have a pretty good set of documentation in, I put a link to the BVIX documentation in the chat. And I think we got a pretty good set of documentation about, how you handle multi-call compared to single call for CCXML. So although that documentation is the BVR AIX documentation, because the browser is the same, it rings true for the Linux code too.
And Mark said again, but separate root document spaces. Is that right?
That's a good question, Mark. Mark, to answer your question, I will have to chat to our CCXML, the developer of that component, and I'll get back to you.
There's one more question from Mark, which I'll let you respond to, and Shabs. Okay, thanks everyone. So we'll carry on now with Shabs, and Shabs, I believe you've got some demos lined up for us. So again, I'll hand over to you.
Thanks, Dean. Great. So I'll basically go from the beginning, from installation onto configuration, some of the commands we have, showing tracing and logging, and some sample calls. So to begin with, I'm in my own directory, and we should have the RPM in the current directory. So we can see here, previously we did pride ourselves on how lightweight this build is. It is only 56 megabytes. So installing should take no time at all. There we go, BVR is now installed, and I should now be able to call in to the sample application.
Amazingly fast.
Hopefully you guys can hear this through my speakers. That's a good point. As you saw, I typed in BVR space -s. Now, this is the main BVR script that lets us use all of our commands. And when you first start up the application, you get the end user agreement, which I've read before.
Again, it's worth pointing out that at some point you'll be able to use a web display instead of this. But at the moment, this is a lean, streamlined.
Exactly. It's much more easily accessible for a demo purpose right now. So you can see on startup, as Rich mentioned before, you'll get some startup trace lines. So in this case, I've not set a license key file. And since it was failed to load, this has been set to one concurrent call, which is technically 2 for outbound calls as well. And the info message, again, as Rich mentioned, it's just a little notification saying that BVR, even though we've had these error and warnings, has successfully started. So with this, we should now be able to call into the sample application.
Welcome to Blueworx voice response.
There we go. So after this, I can show you a few of the commands that we have to demonstrate that a call has actually come in. So similar to the screen that Rich showed previously, we've now had one call come in, one warning, and one error. So from here just reconfiguring the microphone.
Actually, it picks up both sides.
Seems to be turned off. Okay. So from here, I can show you the BVR config that we've currently got set up. Now in this config, we've got all the sample configurations, as Rich mentioned, including the app mapping. Now a user would add extra app mappings for their application themselves and go on from here to make sure they've got other things set up to their liking. So right now, I can go back to the terminal to show, as Rich mentioned, the current trace levels, for example. And these current trace levels are by default all off. The app logging is set to app to allow application logging to go into the log file, and the ifix is currently set to debug so that if there are any ifix jars in place, that these would actually be traced out. So from here, I can either change the trace component individually during runtime. So for example, call, and let's say zip to debug. These would update in real time, and we could confirm this in the BVR-T query command. Now, as I'm going to bring down BVR and change the app mapping, just for some more demonstrations, I will want to change my config to enable trace. So this is simply done by removing the trace section and the trace level. I'm going to keep this to debug for now. So just to call in again, we can see if I tail the log file, that we should, what did I enable? I enabled zip and call. So I can assume that this will definitely produce some trace level lines. So tracing the 0 file and making a call in.
Welcome to Blueworx voice response.
We can see that we've got a great number of detail about the call itself that's just been made. As Rich mentioned, each trace line has a trace ID, the component, which we've enabled as call and SIP, the thread, the trace ID, and some straight text explaining what the trace line represents. So from here, another good thing for application developers that we've got in place is the VXI parser, the VXI interpreter. So if I were to go into the sample application and change the syntax to produce an error, we should, on the next time we start up, no, next time we call in, sorry, we should see some log messages about how the application was passed.
Welcome to Blueworx voice response.
Oh, sorry, I didn't reset the cache there. So, bringing it down and resetting the cache. And then tailing the config. We now get an update on how the VXI application was no longer valid. So this is because the sample application was set to cache, so even though I updated it, it wouldn't have been updated unless I changed the cache parameters on my local file system. So you can see here it gives you the line and the column in which the audio tag was not valid. So going from here, I can now add in a few more applications. I'll go into my home directory and copy over one I prepared earlier. Firstly, I'll bring BVR down. Just to make things a bit more simpler, I'll bring BVR down. So I'll copy this back into the config folder. I could use my system variables, but I thought it would be nice for you to see the file structure each time. And we'll overwrite this. So I've prepared an application which will go through some simple application logging and will tail the log file so that we can see how it's produced. And this time, remember to start it. So I've started BVR with a new configuration file. I guess I can show you guys the kind of changes I've made to be able to support this new application that I've ported across. If I'm typing too fast or going too quickly, just let me know. So, as you can see, previously I explained that if a new user would want to use BVR and update the app mappings, they would simply just add a new app mapping here. Similar to what Rich explained before, you would use this multi-array TOML representation of an app mapping. Now, a good thing to point is that the user is actually in regex. So if we wanted to call into the sample application, we could use not only sample, but 1001 as well. You could also use the special character asterisk to kind of represent other values. So if I had changed this to 1000 star, this would work with 1001, 2, 3, and so on. Now, the app mapping I've used for demo is seen here. I've set the type as VXML, and I've pointed it to an application that I've got hosted in a no cache directory on our local web server. But this has some recurrent TTS, and because of that, I've had to add in an MRCP resource, which Rich has already gone over as well. So here, you can see that I've added a nuance MRCP server under the nuance at hamster2 URI. Now, this will catch all locales beginning with en underscore. So for US, GB, and so on. But for my application, this is simply en US. Because this Nuance server can support TTS, I've enabled that to true. And because I'd like to use the reco, I've enabled this to true as well. Now, as Rich mentioned earlier, the DTMF recognition is optional because this will default to false, meaning that I do not want this MRCP server to do the DTMF compilation or recognition for me. And we'll be using the internal VXMI2 layers DTMF compiler. So those are the only changes I've made to host a new application with Reco and TTS. Now, let's give this a go. I'll be calling in and using my microphone, so hopefully there's not many discrepancies between my speech and the application itself.
Hi, Shattuck. Are you doing the Blueworx voice response demonstration?
Yes.
That does make sense, Shattuck, as that is my only purpose. Is it going well?
Sure.
Good to hear. I will leave you to it.
So as I explained before, it doesn't really pronounce my name the best way possible. Hence, I usually use the name Shabs during my demo apps. But I thought for this reason, why not? So, something good to show is the BVR monitor. Again, since I've reset it, the calls go to 1 and the max call limit has gone to 1. Just for future demos, you might want to, I would probably prefer to set this to a BVR license key I've already prepared. But again, since I'm going to be setting a new BVR license key, I'm going to have to restart BVR. But for this, I'll leave it as it is for now, as I'll only be doing single call tests. So, a good thing to show after I run that application is a number of the commands. So we know that the application works, but I'd like to see some of the SIP messages going in and out. So I run the SIP monitor command. Now I'm going to call back into that demo application and just see the kind of flow of SIP messages going through BVR.
Hi, Shattuck. Are you doing the Blueworx voice response demonstration?
So you can see here we've got all the SIP messages into BVR from my call into that application. Now usually we can use this to diagnose problems or just tailor to a file. Sorry, pipe it to a file. And you can see all the SIP messages going into BVR present. Another useful command would be to actually just tail the logging whilst the application is running to test the application itself and see the flow. So here, I will tail the application logging, and you can see the application logging has come out between each of the confirmation fields and the initial fields for my 2 calls. Seeing as I cancelled the call the second time quite quickly, obviously it's only showing me the first one. Here again, you can see that I've logged out some of the values that's come through. Some other commands that would be useful, again, monitoring in real time, so making another call in. You should be able to see these values update. So as Dean said, we could easily make this a kind of web portal, and we plan to. But for now, this is quite an easy and accessible way to demonstrate how the monitor will work.
Hi, Shattuck. Are you doing the Blueworx voice response demonstration?
There we go.
The development for the web interface is underway, incidentally.
Yeah.
For the UST.
Great. So that's the 2 demonstrations I want to demonstrate, and kind of giving you an overview of the kind of commands we have at the moment to monitor these demonstrations. Is there anything else you guys want to add? Or things you'd like me to show?
No, I don't think so. I think so. You've covered application logging and tracing and things like that, right?
Yeah.
Sorry, I wasn't paying attention to the entire thing as I was answering some questions. But did you kind of explain the differences between the files we have, the log, the trace, the error file, and things like that, just to kind of highlight, I guess, the differences between those files, what you might expect to see in each of them?
Yeah, so I think it's kind of going on from what Rich said about what files we use for what specifically. So as you can see, we've got the single log file. And as you saw before, we have the application logging specifically in this file. So a lot of the time, these would be just combined into one file itself, but we've separated out for the application developers to have a better view of what their application might be displaying. The trace itself, since we've enabled sip and call, gives us a much bigger detail. And this usually wouldn't be needed by an application developer. This would be, as Rich mentioned in his slides, something really used to determine a system error. BVR.out would, I think, due to our key, as we can see here, the key values and the info have been put in there. So if I was to break the config itself, that would demonstrate the parser that we have for TOML. So I think if I remove the general section, Rich, is that correct? That should give me an error. Or just taking away a square bracket. Confidently, of course. See, now BVR is unable to continue due to the configuration file having changed and being invalid. So if we were to fix that, like this.
Your voice skills.
My voice skills are terrible. We have been able to quit.
Thanks, Jeff.
No worries. I think we can actually demonstrate how the res folder has been filled as well. So the res folder, I'll mute that so it stops pinging. So the res folder, we can see it has some VXML2 files in there currently. We've had it separated out into two directories. So a site document and a site DTMF only document. Those are the documentations we have to support default cache handling, sorry. And if we go into the site document, we can see, as I've mentioned previously, this is available for many locales. In the grammar section, we can see that we've got some caching available for each locale. And in the cache folder itself, some more caching based on the audio and the DTMF grammar cache. And I think as Rich correctly mentioned, I can show the different QS commands we have. So you mean running a call and QSing during it?
Yeah, well, just like saying Q and QF work and the QI is quite aggressive.
So the QS BVR command that we've got, we've set two different options. You can force quit, so that forces all the calls to be currently active to be hung up on, allowing BVR to terminate. Or we would do a soft QS where you can set the amount of seconds to wait before doing this force hang up. So if we were to run a call and try and QS, we can see that it's waiting for the call to end before it does any following hangups, allowing BVR to quit successfully. I believe that's most of my demonstrations done, guys.
Okay. Paul, is there anything else that you wanted to add?
No, I don't think so. I was just answering a couple of questions from Mark.
No. Okay. Any questions on the phone about those demos or anything else that you'd like to see? Okay, in that case, if I just bring up the agenda again. So the final topic is about our support process and where to get help. So for this, I've asked Dave Liu to take us through. Dave has more experience than I have and has become a true expert at debugging and diagnosing problems. So I'll hand you over to Dave. Dave, I'm going to pass the control over to you right now.
Okay, thanks, Dean. All right, so yeah, my name's David Liu. I'm the senior support engineer for the products. I've actually been in the support team since 1999, although previously I have worked in both the development, test, and the level 3 support teams when we were as part of the IBM team. But currently, I'm now supporting this product and the AIX products. The objectives today is really just to go through the Blueworx support team, who we are, explain the online support process, and really to summarize some of the stuff that Rich talked about earlier with regards to the problem determination tools for the Linux product. So who are we? The Blueworx team, the support team, it really consists of myself at this point. I'm based in Raleigh, North Carolina. We also have the support team based in Hursley. They used to support the European countries and the Middle East. But right now we're combining a lot of the effort from support together to provide the complete support for the Linux product. But primarily, you'll be contacting the me based in the US side of things. For the support, the hours are from 3 o'clock to 7 o'clock. 3 o'clock to 5 o'clock Eastern time. That covers the UK time when the Hursley guys come into the office, up until the time that I leave the office at 5 o'clock. During that time, you will always be able to get hold of a support engineer, myself or somebody in the UK, and we'll be able to assist you in any issues that you have. That covers all the severity issues from Sev 1 to Sev 4. For the out-of-hours support, we do have 24/7, 365 support. All you need to do is open up a ticket with the appropriate severity. We will automatically be paged out, and we will respond accordingly for system down issues. So basically, the principle or the support process hasn't changed in the transition from IBM to Blueworx. You'll be talking to me. We'll be communicating over the phone, email, whatever process you prefer, and I'll engage the relevant development teams to resolve the problems if needed. The support doesn't just cover system down issues. We will do defect support. We do Q&A. So we'll basically do everything we need to answer your questions in a timely manner. And the way we're going to do that is primarily ticket-based, and we'll go on to that now. So how do you get help and the support process that's involved? If you haven't already subscribed for a user account, then the URL that's on there is your main landing point to engage support. What you'll need to do is register for an account. We will then receive that information, set up the account for you, and then you'll be able to create the tickets. And that's really all there is to it in terms of that process. The following sets of screens really just detail that registration and ticket creation process. So when you go to this, the first page, and you click on the request for registration, you're going to be presented with this screen. And really, you just fill it in the comments section. All you need to do is put in a statement saying, I'd like to create or request a user account to open against the tickets for the Blueworx product. Once you've done that, you'll receive an email notification from myself or from one of the support team verifying that your account has been created. Then you'll need to create a password. And once you've done that, you can then go to this page here, and if you have a problem, click on Submit the Ticket. You'll be asked to sign into Blueworx, and after you've done that, you'll be presented with the main Blueworx voice response support portal page. Don't worry about this content, it's a bit small. I'll go into it on the next page. But this is really the main page you'll go to. If you're always logged in, you'll see all of this information here. And this page will get updated pretty frequently. And within this page, we've got quite a few sections here to help you as a developer or the administrator of the system, at least information that you should use first of all in trying to understand whether or not we've got a solution to the problem, or if there's any updates that you might need to be aware of as regards to how we resolve issues. So in the news section, this is where we would make new announcements. If you see on the top line, we recently also announced the version 7 of BVR for AIX, and we've also got a lot of articles that we've ported over from the IBM websites. We also have an FAQ, the first one in that list here, how do I upload debug data? That's going to be important, I guess, for a lot of customers in understanding how we do the upload process to get data to the support teams. The documentation section, that will have links to a lot of the product docs that we have. We also have a separate link as well to the current version for 6.1, but we'll be updating that soon for the 7.x versions of BVR. We also have extensive troubleshooting links here. This is primarily AIX based, but obviously this is going to we'll update this once we get any issues that we think will be helpful for the Linux developers if they encounter any problems. But this one here, it just contains useful hints and tips that we found over the years, and think that they're useful for the customers in debugging issues. The other section is security bulletins. Obviously, these days we have to be very aware of the impact of any vulnerabilities or exposures to viruses, and if there's any requirements that we have to pass on to the customers to say you need to update the systems, this will be where we make those announcements. And the last one is Fix Central. This is going to be the links where we provide all the latest fixes for the BVR products. So currently, if you see there, we've got some updates for the AIX 6.1 version. Obviously, as time progresses, we'll update that with the latest fixes for Linux and the AIX platforms. I've got to say, if there's any questions during this, please feel free to ask. Okay. So in order to open up a ticket, it's very simple. I've highlighted that little button, submit a request. Once you do that, you're going to get this screen here. Again, everything here is self-explanatory. Enter a subject, a description. The priority is pretty important. I'd suggest that we have 4 levels of priority. The highest one will be urgent. That will initiate the page out. But I'd suggest you don't really use that in a production system down scenario, or one which you think needs an urgent resolution by the day, by an end of day or end of week. The other ones you can use. Low would be for Q&A type questions. The platform, there'll be a drop-down list for the version of the product that you're currently using, so be sure to specify the correct one. The other ones are just drop-downs with yes/no answers, so nothing important there. But the next screen here, this is where I think it will help me as a support engineer at least understand the issue. So can you recreate the problem? A lot of times they only happen once or twice, and it's not easy to recreate the problem. I think having that information, if you can easily recreate that, then put that in there. Provide information about how you recreate the tests, what kind of scenario you have, Just as much information as you can on how you do that test. And that will help me if I need to try and recreate that within one of my local machines. Another important area is recent changes. It's possible there may not be any changes on the BVR machine, but there may be changes on let's say on a network or on an application server or anything that you can think of that you think may have affected the behavior of the BVR machine. That will then give us an idea as to where a potential problem may be, and can allow us to focus on that area. And lastly, have you taken any corrective action? Some customers may just decide to restart the system and it works, and that may be the corrective action. But then you'd like us to do some analysis as to why that occurred. So that would be useful to know. Maybe you've applied the PTFs and that still didn't resolve the problem. Again, that would be nice to know. Anything you try to do in terms of problem determination, let us know in that section. That means then I don't have to ask to say, have you done this, have you done that? If you provide that information before, it's going to save time in doing the troubleshooting issue. The last item of note here is attachments. Zendesk, which is the product that we use, has a 20 megabyte, 20 megabyte limit on the size of the file attachments. You'll get a warning if you attempt to attach a file that's too large. So you need to be aware of that limitation within Zendesk. However, we have a solution for that, which I'll detail a bit later on. We have a separate FTP server available for larger files. Once the ticket's been created, you'll get this type of screen here. You'll see that the status is marked as open. That will mean that the ticket's been received and that somebody from the support team has noted it but hasn't taken any action at this time. It could be that we're working on the issue or we haven't provided an update yet. So let's assume that you've opened up the ticket, but you didn't previously provide any data or provide more data, and you wanted to update that ticket. At this point here, you would update. You could put your updates in the section with the green arrow. You can attach your files, shown again with the blue arrow, and then you hit the submit button. The only point to note here is that if you only decide to attach a file, but then click the submit button, the data will not go through. It requires you to enter at least a line of text in that text field to say, hey, here I've attached a new file. And that way we'll actually see the file. So there are cases where customer says, oh, I sent the file, did you not receive it? And this is primarily the reason why we didn't get the file, because there was no text description attached to it. So once a support engineer has looked at a ticket and has made an update here, I've made a statement saying that I'm working on the content and it's now available for review. I set my status to be waiting for the customer response. From your side, you would see that this says waiting your reply. So that means that if you have a subsequent update to make, then you can do that at this time. We also have the ability that if you feel that, let's say, I've answered your Q&A or the problem's been resolved, the fix has worked, you can mark that ticket as closed. At that point, no further action takes place, and this ticket will be marked as closed on my side. I also have the option to do this with your approval to close the ticket from my end. Previously, that wasn't something you could do on the IBM PMR process. It wasn't as easy. But here, from in Zendesk, you can mark a ticket closed yourself without even having to inform the support team. Earlier, I talked about the file size limitation, and we created a document to detail the options available to send large files. So I have a link there on how to upload debug data, but specifically it points to an FTP server. Once you go to that link that's shown there, you're going to get this window displayed, and again, you just fill it in, you attach the files, providing as much information as you can, customer name so we know who it's coming from, the version you're running, and any other descriptive information that you want to put into that update. That will then create an entry on the FTP server, and we can fetch that data and use it just as normal. So that basically describes the online support process. I'd suggest that's a primary mechanism that you use to open tickets. Everybody in the Hursley team and myself, we all see the tickets. I'll be the primary contact, but you will definitely see updates from the development team. So we're one big support team. As a quick reminder, Richard already talked about some of this, but this is some of the things that I look for, or especially from a support standpoint. And excuse me. So the logs and traces, these are all going to be useful. They contain a lot of the trace and log information that we'll use in trying to determine what's happened with the call behavior or within BVR itself. You can configure the trace and log settings in the bvr.config file, and the log files are available in the BVR logs directory. One thing that is much improved on the Linux version as opposed to the AIX version is that we can change the tracing dynamically in real time. In the AIX world, a lot of you may know that, sometimes we'd have to request you to stop BVR and restart it to enable the tracing. This meant some downtime, and you know, things would be reset and you may not recreate this. Obviously now we can do this using the BVR-T command, and you know, you can run this without having to shut down BVR. I think it'll be a lot more useful for diagnosing problems on this platform. And the example I've given here just shows that initially we set all the trace flags to be off, and then we just enable the VXML and the SIP for debug and trace. So that therefore we're just focusing on those two components. It's up to you as the customer whether or not you want to do that before opening up the ticket, or if you prefer the direction from the support team. I think if you're confident enough to know which component you want to set, then you can do that. However, if you're not certain, or you don't know where the problem is, you know, once you open the ticket, we'll advise on what trace flags to set. Although I put here traces will be used by BVR support and they're not intended for use by customers, given the fact that they're all ASCII readable, you know, I don't think that there should be any problem if you feel that you want to look at the traces and understand what's going on, you know, within BVR. The log files are more intended for the customer use, but you know, if you feel confident in looking at traces, then you could certainly do that. Again, this is just to reiterate some of the stuff Richard talked about. These are this is the trace header and the different levels of tracing that you can enable and how you would set that. The default is off normally, so you might want to set that up at least for minimal tracing if you want to do that. And you can also override the specific component traces by using the component trace level header as well. And what will be very useful from a support standpoint is the BVR problem tool. This is the primary data that I will look at initially when understanding your system and what's going on in your environment. The syntax is shown there, but in most cases you will not even need to use the -L, -S, or -keep option. All you need to do is enter BVR problem and then specify the output directory. In most instances, you can just use /tmp for that, or temp. And that's it from the support standpoint. I hope you never have to call me, but that information is there if you need it. Any questions? Okay, assume everything's good. Thank you. Back to you, Dean.
Thanks very much, Dave. Just switch back to me for a second. So that really wraps up what we had for you today. But at this stage, we still have all the engineers and architects here. So if you have any questions, now's probably a great time. Otherwise, you can contact us anytime at our email address or website. But for now, I'll throw it open. Does anyone have any questions?
I am here, Dean. I wanted to jump back on and just say thank you for spending your morning with us. We certainly do appreciate it. I think I have to apologize because some people had difficulty getting in. We had a really good turnout on this. If you have some team members that couldn't get on, please point them to the email I send you with the recording so that you can get to it. I also think we have some follow-up to do. You know, we talked about CTI quite a bit, and we've got some alternatives and solutions that we can that we'll put in an email and send out to everyone as well. But don't hesitate to contact us for anything. We are small, nimble. We are aggressive. We are very entrepreneurial, and we believe we've got a platform that we can take to market that will compete with anything out there. And in many ways, what we have, no one can touch as far as reliability, scalability, running on multiple operating systems like Linux and AIX. We have a message center product that we didn't talk an awful lot about that if you have any interest in, please contact me. And we may outline that at some point in time. So we appreciate it, and we'll give you your day back and have a great day.